Everyone, good morning. We'll get started shortly here. Just give us about 5-10 minutes. We're still getting some technical things going on and resolving it. So just give us about 5 to 10 minutes and we'll get started pretty soon here, okay? Good morning, everyone. So my name is Ayrton Coles, and on behalf of our Tennessee Transportation Assistance Program, and with help from TDOT here that allowed us to use their auditorium here in Chattanooga, Tennessee, and also in collaboration with McCain, Q-Free, and Unix Traffic, we welcome all of you to our ATC cabinet and controller interoperability. All right, we'll be here until 3:30 this afternoon. Of course, we're going to have several breaks and break for lunch. But thank you everyone for participating. And I would like to go ahead and just go over the presenters. Eric Itzel, ITS engineer from Swarco McCain. Mr. Itzel's current role is an ITS engineer for Swarco McCain. In this role, he presents new innovations, provides extensive on-site training, and performs other on-site field services to agencies across North America. He also collaborates with other technology and innovation providers in the intelligent transportation sector to better further the industry. Okay, let me just, actually, I forgot to do one thing. Let me share my screen. That's probably going to be easier for you guys too. So apologize for that. And all right. And when not working on site, Eric works from his home office in Thomaston, Maine, or at the company headquarters in Vista, California. We also have Matt McCain, technical lead here from Q-Free. Matt is the technical sales lead at Q-Free with nearly a decade of experience in traffic management. He previously worked as a traffic signal shop supervisor and technician, gaining an extensive expertise in signal cabinets, hardware, and troubleshooting and system integration. Matt has hands-on experience with various signal controllers, detection systems, and network configurations, as well as a passion for advancing traffic signal technology. He is an IMSA certified as a Traffic Signal Technician 3, Bench Technician 3, and Traffic Signal Inspector 1. In his personal time, Matt enjoys collecting traffic signals and have even built a fully operational intersection in his basement. Nikita Singh, Senior Software Developer with Unix Traffic. Nikita is a skilled software engineer with a master's degree in computation and computer engineering from the University of Houston, specialized in embedded systems. At Unix Traffic, she focuses on developing connected vehicle to everything technologies, including the blade controllers, roadside units, and onboard units. Her work spans application development, testing, and integration for both vehicle-to-vehicle and vehicle-to-infrastructure communication. From concept to deployment, Nikita is dedicated to delivering seamless, forward-looking solutions for safer, smarter transportation. Jay Ham, system engineer from Unix Traffic. Jay is a systems engineer with a degree in civil engineering from the University of Alaska Fairbanks. He began his career in traffic analysis and design before joining Unix Traffic, where he worked on the Miami-Dade Bus Traffic Transit, BRT project. There, he focused on CPAC programming and deploying 2070 controllers along the BRT corridor. One thing that is pretty unique about this presentation, I think all of you already realized that, it's probably one of the first times that we have that many different vendors working together on a presentation. Okay, so that's very good to see. And I know that most of you have already done that, but let me just go through my housekeeping items here. Please sign in, typing your full name in the chat box. If you have more people with you in the room, just make sure that everybody's name is in there. If you need to request for your to unmute your audio, just let me know and I'll be glad to do that. Or just ask your questions or comments, put it on the chat box, right? We'll try to address that to everyone in the meeting. I will be working on your PDH certificates for this session, but just give us about 2 weeks to go through the Zoom analytics and everything else, all right? So we have not practiced for this, right, Eric? We may have some technical issues along the way, so hopefully everything goes smooth after the initial issue we have here in the beginning. But we also have about 10, 12 people here in the room that we would like to acknowledge and say thank you for participating. Okay, so with that said, I'm going to stop sharing and let you share your presentation, Eric. And let's just make sure that your sound there is working, okay? Say it again.
Sound check. Testing, testing. Okay. No, it's a Crestron. So you gotta, okay. Testing. All right. Yep. All right. Oops. Backwards. All right. Good morning, everybody. For those of you here at the TDOT facility in Chattanooga, welcome. Thank you for coming. Everyone out there on the Zoomverse, thank you for attending. This is going to be a fun session today. Like Erickson said, this is the first time that we all can think of that we've had so many vendors here to talk about the new ATC cabinet platform, or even just talk about a common platform in general. So this is really fun. This is very exciting. This event kind of genesis from a previous event that Erickson and I did in Sevierville earlier this year, in Sevierville, Tennessee, excuse me. Not everybody knows where that is. I thought, you know, everybody, I do these sessions with Erickson once or twice a year, and you guys got to be getting tired of hearing my voice. So let's bring in others. Let's bring in the industry and talk about really the same thing, but talk about how we're moving into the 21st century. So that's the genesis of this presentation. So I'm really thankful for Matt from Q-Free. Although now, full disclosure, Matt's last name is McCain, no relation to Jeff McCain, the founder of McCain Manufacturing, McCain Inc. So for the sake of this presentation, we're going to call Matt Q-Free, not Matt McCain. And then of course Nikita and Jay from Unix Traffic. Former colleagues of mine from my time at Unix. So I'm really excited that they're all here. Today's session is a comprehensive review of the features and benefits of ATC cabinets, and then how those features and benefits mold into the modern advanced transportation controller. So it's kind of a hybrid session. We're going to lean into ATC cabinets first. We provided 2 McCain 358i backpack cabinets. And you can't really see it behind the Q-Free controller, but we have a McCain Flex, a Q-Free XN1 controller, and a U-Traffic blade connected to these cabinets. And they're all driving the cabinets, same configuration. Now, the reason that we use backpack cabinets, because they're easier to ship. And plus, all of our cabinets are devoted to trade shows coming up. So these are cabinets that are issued to Swarco McCain outside sales representatives. So my good friend Tony Jutner in Minnesota sent me his complete stock of demo cabinets for the sake of this. So if you guys, especially for the audience here, if you have any questions or want to come up and see the backpacks during break, you're welcome to come up and fiddle with them. Just don't break them. I kind of estimated the breaks. Breaks, of course, the times are Eastern Standard Time as we're in Chattanooga. We're gonna shoot for a break around 10 a.m. lunch at 12 noon, and then afternoon break 1:30, whatever. But we'll also just kind of wing it and see how this goes. I do want to say before we get started, thank you to Ayrton and the Tennessee Transportation Assistance Program, and also to TDOT for letting us use this beautiful facility. So thank you guys for that. That's extremely helpful for this. And Sevierville's tired of me using their space. No, just kidding. Our objectives today, thing 1, understand the features and benefits of ATC cabinets and how they're superior over legacy cabinet platforms. So your NEMA cabinets, your Caltrans cabinets and such. Review ATC controller integration tips and best practices. So this is where you guys are finally going to hear me shut up and let Matt from Q-Free and Jay and Nikita from Unix come up and talk about their solutions and how they tie into ATC cabinets and how we can start engineering and implementing the intersections of tomorrow. And then talk about use cases and success stories. That one's kind of a floating objective. We'll be like throwing out various use cases and stories as we go through this presentation. So this last point, the last point in blue, I want to emphasize, yes, we're competitors. Swarco, McCain, Q-Free, Unix, we all sell controllers. We all sell software. But today, the 4 of us are not. Today, we're friends, and we're aligned on the importance of using ATC cabinets and controllers and modern technology to make our intersections safer, more efficient, and cost effective. So we're in this one together. The last thing before we get started, Scott Evans is essentially the father of the ATC cabinet. He worked at EDI, Everly Design. Oh, bugger. This is the one with the timer, so we got to fight that. We'll have to get that on the break. For everybody's awareness, my laptop crashed right before we got started, so we had to recover the presentation, which is why we started 10 minutes late. So Scott Evans was the Vice President of Engineering of EDI for 29 years. It was his idea to commission the ATC cabinet, building on the successes of the previous cabinet architectures. He reached out to the Vice President of Engineering at Swarco McCain, it was McCain back then, and he convinced, and they together convinced the owner of Everly Design and the owner of McCain, Jeff McCain, to pursue the ITS version 2 cabinet, which became the ATC cabinet. It took him 3 years to build the cabinet. And he retired in 2017 from EDI. And then I worked with him on another project, the cyber cabinet project. And unfortunately, he passed away. So he was a great guy. And I told everybody that for this year, he passed away in December of last year. So I told everybody this year that I was going to throw a tribute slide in every ATC cabinet presentation. So this one's for Scott. All right, so let's talk about our standards and our companies. Quick introduction, and we worked this out beforehand, but we just want to talk about who we are. Q-Free, Matt Q-Free, Matt McCain is here from Q-Free, representing the company. I love their saying here. We go to work every day hoping to do 2 things: improve mobility and make the world a little better. That's a great saying. That's a really positive approach. And you know, when we go to work every day, we're commuting to work. Typically, we're going, you know, we're leaving our houses, getting on the roadways, and regardless if we're getting on public transit or driving or a bicycle, we're using the product that we're supporting, and that's the road network. That's transportation. So Q-Free's commitment to making the world a little bit better is a very, very good commitment. Unix Traffic. I like this company. Uniting what's next in traffic. They're an innovator across the world. They're not just a US-based company. Unix, Q-Free, and Swarco are actually global companies. And Unix has offices and deployments all over the world in the intersection and mobility space. And they're a forward-thinking company. They're an innovator. And then Swarco McCain, my people. Don't get excited, Matt. I didn't change your first name. McCain was founded in 1987. Here in the States, or here in North America, everybody knows us as McCain. McCain Traffic Supply, McCain Inc. We're a cabinet manufacturer. We make signal heads, we make controllers. And then over the years, we acquired other companies until we too were acquired in 2016 by the Swarco Group. They're owned by the Swarovski family out of Austria, another global company. So we work with Unix Traffic and Q-Free on the other side of the ponds in Asia and Middle East and Europe and such. So of course, we're competitors in those spaces too, but we're also collaborators. So our core values are carried into our products. And we were a pioneer in the industry by co-developing the ATC cabinet with Everly Design. So that's us. Now let's talk about these products that we're reviewing today. And I want to start out by stupid timer. I want to start out by going into the standards themselves. Quick review of the traffic. Advanced Transportation Controller Standards. Now, this is funny because we actually use this acronym for different platforms. So there's an ATC standard for traffic controllers, an ATC standard for cabinets, and actually an ATC standard for an application management software that runs on some of these controllers. I'm beating on the Q-Free controller because they were the first ones to use the API. So I want to define the standard so we know what we're talking about when I say ATC. So ATC 5201 is the first traffic controller hardware standard. The latest version is 06.37a. That defines how the traffic controller is built, how the specifications inside the unit itself, specifications of the engine board. It aligns the fact that that all of these controllers have to be running a Linux operating system. So this blade, this XN1. Yeah, Matt, I'm just going to give you dominance over the McCain, so I can do that. The McCain, the Q-Free, they're all running Linux operating systems. So we're done with proprietary or legacy operating systems or machine language or anything like that. They're all aligned. This helps us with interoperability. This helps us with cross-compatibility. And this makes sure that the industry is designing products that end users can confidently invest in without feeling like they've been stuck. Brief example of the ATC 5201 engine board. This is the key. This is the heart of all three of these controllers. This is going to be a day. This little engine board is seated inside the controller. If we took all three of these controllers apart right now, there's a board inside of each one that looks almost the exact same. Now, as manufacturers, we do have control over the design and layout and some of the more minuscule features, but the idea here is that our engine board will fit in any controller. It was a take on interoperability. Didn't really work out so well. It's been the ATC standard's been around since 2005, ATC 5201 standard, but this allows us to build on each other's architectures. The other ATC standard that we're going to talk about today, the ATC 5301 standard, this is the cabinet. So both of these McCain backpack cabinets, these 358Is, oops, these 358I cabinets, these are built to the ATC spec, even though their architectures are not standard ATC cabinets. If you go to any ATC cabinet that's around here, there's a lot up in East Tennessee, or we are in East Tennessee. There's a lot up in the Great Smoky Mountains area, Sevier County. And you open the cabinet doors, they look slightly different than this, but the architecture is still the same. These are technically ATC cabinets. They're just very much more convenient to haul across the country. So the ATC 5301 standard defined how the cabinet had to be built. So it's a functional standard, or just defined how the cabinet had to operate. Excuse me. It defines how the serial bus protocols communicate, so how the controller communicates with the cabinet devices. As you can see, there's a lot of flashy, blinky lights inside these cabinets. That's an intelligent communication between the controller and the assemblies. And then it provides baseline operational specs for electrical logic signals and such. It is rather vague, though. It's called a functional standard for a reason. This block diagram here is all we had to work with as manufacturers to build this cabinet. So this allows for customizations by manufacturers. This is why that if I had a Trafficware ATC cabinet, a McCain ATC cabinet, a Mobitrex ATC cabinet, a Peak ATC cabinet, and I'm missing one. Shoot. Econolite. The Econolite ATC cabinet all sitting here, they would all look slightly different, and their assemblies are not interchangeable. So agencies like the state of Maine, they invest in different ATC, or they purchase blocks of ATC cabinets, and they have Trafficware, McCain, Econolite, and Mobitrex on the street across the state of Maine. So these cabinets are, they all function the same exact way. So for technicians, they can troubleshoot them using the EDI troubleshooting methods, using block diagrams and such that we as manufacturers create for them. But as far as parts and interchangeability, they have to stick with, you know, replacing an assembly that is made by the same by that cabinet manufacturer. The other standard I want to actually go talk about, which this is a typo, it's not really a standard, Caltrans specification, Caltrans TES, Transportation Electrical Equipment Specifications. feel like there's a demon in my laptop today. The current release is 2020. This is a state spec. Caltrans came up with this spec in 1978, or they developed, they've had several revisions of T's. The previous was 2009, but this is a technology spec, defines the operation and design of cabinets, controllers, and auxiliary devices. To me, I believe this was resource material for the ATC standards because Caltrans was the first to tackle interoperability, cross-platform compatibility. Everybody who builds a cabinet they have to look a certain way and they have to all operate in the same way. So Caltrans has led the charge here. So to me, it's I always take Caltrans T's into account when I think about how the ATC was developed. And then the last standard I'm going to talk about is NTCIP, National Transportation Communications for ITS Protocol. The 1202 group of standards defined 1202 is part of a family of standards that provided protocols and standard objects for various communication, or various technology communications. So communicating with an actuated signal controller, communicating with a roadside unit, communicating with CCTV, communicating with weather stations. So there's an entire suite of standards in the NTCIP group that set up a standardized or that standardized communication to devices across the industry. So if I have an NTCIP 1202 compatible controller, which I do, the McCain, and I connect it to a third-party central system, that central system can communicate with my controller. It can monitor, control, and analyze it. If Q-Freeze, which it is 1202 compliant, they can do the same. Unix is, they can do the same, which it is. So the idea here is to get away from vendor lock-in. All right, let's talk about the features and benefits. What's the ATC cabinet? Why is what I believe is the cornerstone of the 21st century intersection? Let me just play with my slides. You guys can try to back end edit this, see if we can fix that. So a long time ago, when McCain launched the ATC cabinet platform, the marketing group came up with, or marketing and sales and everybody, the high ups came up with 3 key concepts, 3 pillars that the ATC cabinet is built on. And as a hierarchy, I'll read these out. Safety, efficiency, and then cost. Safety, this is what all of this is all about. We were in a world where cars couldn't crash into each other, pedestrians weren't ever, if their safety was never compromised, if you know, all things that Wired magazine claims by 2040 we won't need intersections anymore. If all of those things were true, we wouldn't be here. We wouldn't have jobs. But guess what? That's not true. So thing 1 is safety. We want to get on the road and get off the road without any harm or damage to our personal selves or property or someone that we really care about. So that is first and foremost our entire approach to intelligent transportation. Second, efficiency. It's our job to make the roads operate more efficiently for all of the road users, and also it's kind of fun, you know, as you're implementing new timing or installing new tech or whatever, and all of a sudden on one day the road was just a parking lot, and then you install the new thing, or you put in the new timing, and then you just watch moving platoons down the road. You go, hey, you know what? I did my job today. This is cool. That's the fun part. And then, of course, costs. You're factoring the total cost of ownership of these systems. ATC cabinets have been on the street for 10 years now. ATC controllers have been on the street for 15, 20 years now. You know, and some people say, well, why is that? You know, the investment's so much higher. Well, this costs more than that used to cost and stuff like that. Let's think about the total cost of ownership here. Is it easier to use? Does it require less labor and soft costs? Is there a value add to where you don't have to buy a bunch of different things to do what this new box does? Or I don't need additional traffic cabinets to operate a complex intersection because this one traffic cabinet, well, not this little guy, but you know what I mean, because the traffic cabinets themselves can take on a bigger role. and then again, cutting down on investment and hard costs, maintenance costs, and soft costs of labor. It costs $400 to roll a truck for a technician to go to a location to service a signal. That's the industry average. It doesn't matter if you just go out there and it was a slug on a terminal and you scraped it off and hit reset. That still costs $400. All right. Before I talk about ATC, let's talk about how we got here. I'm getting really tired of this slide, but it does tell a lot. When I first got into traffic up in Sevierville, Tennessee, this is what we use: NEMA TS1, original design 1976. Load switches designed from 1950s components. Flash transfer relays from 1930s components. The controller was the power supply in the TS1 cabinet. One thing TS1 brought to the table though was standardization. It gave us the ABC connectors. Well, not this. I don't have any TS1 controllers here, but it gave us the ABC connectors that standardized that I could take any manufacturer's controller that's TS1 compliant and put it in a TS1 compliant cabinet, and they will operate the basic functions of that intersection. So before that, it was the Wild West. Electrical mechanical cabinets, solid state cabinets that were custom designed. There's still a lot out there actually, and it's really, really creepy to see them because it's just absolutely just super proprietary for whatever solution that somebody decided to buy in 1968. There was no STLC interconnect in TS1. So that means that the controller and the monitor were not intelligently communicating. The reason there was no STLC interconnect in 1976 is because it didn't exist except for in a laboratory environment. That's how far back this stuff goes. Matt and I drove down from Sevierville, East Tennessee, to Chattanooga, and I know you guys are from here, but I gotta say this for the Zoomers. It was an hour-and-a-half drive, and every intersection we drove through, or almost every intersection we drove through, was a NEMA TS1 cabinet, and they all looked 30 or 40 years old. 1978, Caltrans came up with the state spec, and kind of their answer to everything that TS1 brought to the table, but where they saw for room for improvement. So they introduced a rack mount cabinet form factor. They had a standardized C1S connector to tie the controller into the cabinet, to couple the controller with the cabinet. Modular design so the cabinet was easier to service. Now, it's still no SDLC interconnect, which to this day they don't have it, because it wasn't around back then. So the monitor and the controller couldn't intelligently communicate. 92, NEMA updated their standard to TS2. They introduced NEMA TS2 Type 1 and NEMA TS2 Type 2. Now, this blade right here is a NEMA TS2 Type 1 compliant controller, because it has this little A connector and it has SDLC. So I could take this blade out of this backpack cabinet and put it in a NEMA cabinet. My Flex, the Swarco Flex controller is actually, it has a Caltrans connector on the back, so it too is a hybrid, and the Q3 is a NEMA. Oh shoot, I didn't even see your power cord. Sorry, Matt. This is a NEMA TS2 Type 1 as well. So when they introduced when they introduced TS2, they brought in STLC. They increased the cabinet capacity from 12 channels maximum to 16 channels maximum. They changed the terminology. The cabinet monitor or conflict monitor is now called a malfunction monitor because it's intelligent. The controller says, hey, this is what I'm doing. And the monitor says, yes, I see that. You did turn those lights on. So it becomes a more capable platform. I'll talk about that later. Then 2006, the feds got involved with and constructed the ITS cabinet. This was a merging of NEMA TS2 and Caltrans. There was a serialized cabinet with SDLC, but it was a rack mount form factor. This thing was a monster, up to maximum of 28 channels for outputs, a whole lot of load switches, and they introduced the serial interface unit. So it was a stepping stone to get to ATC. Now, when we introduced ATC, we combined the best of all the worlds. NEMA TS2 SDLC, Caltrans rack mount and modular form factor, ITS high capacity. But we also introduced the fourth element, modern technology, a NEMA load switch, 1950s triax, flash transfer relays, 1930s, AC powered flash transfer relays. So if you go to the closest water plant, water or wastewater, but water plants are more pleasant, or you go to you open up an HVAC panel, you're going to see miniaturized electronics, solid state relays, micro switching technology, PLCs, and everything. So why are we using a load switch that's this long, that's made of aluminum, because it generates so much heat? Oh, we're using that load switch because back in the day we used incandescent lamps. We don't use those anymore. Okay, so let's factor out what we designed the old cabinets for, because that's no longer relevant. The solutions that those cabinets needed to solve for are gone, or they're mostly gone. There's a couple. We drove through a couple incandescent signals here in East Tennessee yesterday. So by factoring in modern technology, miniaturizing the components inside the cabinet and making them more efficient, now we can design a completely new platform for the 21st century. And fun fact, the ATC cabinet is the only cabinet that is built from the ground up in the 21st century, thanks to EDI. So the question that everyone asks, how is the ATC cabinet better than the previous generations of cabinets? This is a nice way of, this question was asked to me in a different way last year, and this is me smoothing the question out a little bit. Don't they all basically have the same job and by turning lamps on and off? Yes, that big metal box on the side of the road, its primary job is to turn lamps on and turn lamps off, based on detector inputs from head push buttons and vehicle detection and such. So if that's the primary goal of the traffic cabinet, why do we care about this new advanced thing that is more complex, and now we have to go back and learn about it and everything, when we had this all figured out with TS1 or TS2? Let me show you. Let's talk. I don't know why I didn't take you up on that clicker. That would have been much more easier than walking across the room. So first of all, technician safety. Show of hands for everybody, and including you guys on Zoom. Who's been shocked by a traffic cabinet? You can unplug, Ayrton. You can unplug my little Logitech dinger. Okay. So being shocked by a traffic cabinet, especially a NEMA TS1 cabinet, is not that difficult. There's over 100 exposed electrical points of contact of 110 volt AC. Okay. When we're going to design a cabinet, let's solve for that, because it doesn't take much voltage or much current, excuse me, to stop your heart. And most of us are like, oh, I've been shocked, it's no big deal. But also, you know, if you get shocked 1 in 100 times, 99 of the times, or you get shocked 100 times, 99 times, it was no big deal. What would you take a chance for that 100th time to be a real problem? I've heard stories of people getting stuck. They reach into a handhole and they make contact with something, and their muscle seize, and they have to be beaten and kicked away from that handhole. And I've heard the same stories of cabinets. So let's build a cabinet that number one, prioritizes on technician safety. So we minimize electrical points of contact. We no longer have signal bus bars with screw terminals. We have Phoenix connectors, where we terminate the wire into a molded Phoenix connector, which then seats into the cabinet. All the circuit boards and PCBs are covered with permanent plexiglass shielding. I say permanent because a lot of cabinets have been built over the past 20 years with removable plexiglass shielding. They're only as good as the technician who puts them back in after they service the cabinet. Switches, connectors, harnesses, all the things are covered with an electrical insulator. I used to shock myself every time I'd adjust the little needle dial, the temperatures, the fan temperature dial in a NEMA TS1 cabinet, because it's right next to the door switch. The door switch is switching 110 AC to turn on the cabinet lamp. And then cabinet thermostats, speaking of which, are plastic. They're Stego thermostats. These are just simple controls, industrial controls, thermostats that are used in service panels. So they're all plastic. Again, you can't get shocked. Next safety feature, dark signal detection, immediate dark signal detection. So if you lose a load, a green, yellow, or red on any particular channel, let's say a neutral opens up or something like that, and then you can no longer light up those lamps. Then in a NEMA cabinet, you'll have to cycle through, wait for service and cycle through until you get a multiple indication fault, which is ambiguous. In an ATC cabinet, because we can monitor voltage and current, the minute or the moment that load opens up and those lamps are no longer lit up, the switch packs know. The switch packs report back to the monitor and they say, hey, we got nothing. We're not turning on a lamp. I got voltage, but I'm not turning on a lamp because there's nothing. I'm not getting any current consumption. So go to flash immediately with a lack of signal fault. And someone might say, well, I mean, NEMA, it'll cycle through once and then go to flash. Do you want to take that risk of that 90-second cycle, or maybe it's a long coordination cycle, so 180 seconds where that load opened up because a rat chewed through a neutral? 180 seconds is plenty of time for someone to get T-boned. So ATC cabinets go to flash immediately with a lack of signal faults. Now, in my little picture here, this was December of 2023. I took this picture 2 blocks away from my headquarters in Vista, California. So down here, the little red arrow, that's Swarco McCain headquarters. This is my hotel where I typically stay. And this little gray, that little gray spot on the road, that's this intersection. That red lamp was out for 3 months. Oh, actually, I assume it's a red lamp, but what color is that? One would never know. So the problem is, and full disclosure, because somebody actually did this to me last year, they pulled this up on Google Maps and they said, hey, behind that map snip that you put there, there's a second signal. Because there's a second load on that line. I'm like, well, tell that to your grandmother when she pulls up and she was taught in driver's school to look straight ahead and the signal's dark. And then she has to make a decision, your grandmother, grandfather, new driver, whatever. They have to make a decision because the road or the intersection is not telling them what to do. We're all supposed to follow the green, yellow, reds, but if we don't have one, then we have to make a guess, an assumption. And again, there's a 1% chance, or 1% chance that they might make the wrong decision, and they might think, oh, I bet that's a green, and they pull out into traffic. I hate to be so blunt, but there are some motorists in this country, in North America, that don't make the best of decisions. I think that's the nicest way to say that. Next safety benefit, flasher alarm monitoring. The flasher system in a cabinet is the backup operation. The controller goes offline. Oh, you bugger. Spoiler alert. If the controller goes offline, or something happens, field wire short or anything, the flasher, the cabinet will actually power down the flash transfer relays or power them up in a Caltrans. And then it will decouple the controller from the cabinet outputs. And then the flasher unit takes over and it runs the backup flash system. Well, what if the flasher fails? Under normal operation, you'd never know. You only would know when you go to flash and then the signal goes dark because your flasher system's gone. First time I ever saw this was the city of Roanoke when I went there to work with Matt 3 years ago, actually. We turned a signal, we put a signal in flash, and the technician that was there, he said, hey, I'm kind of new at this, but those shouldn't be dark, right? So we need a cabinet that monitors the flasher system. That's not possible in a Caltrans or a NEMA cabinet. NEMA TS1, TS2, TS2 Type 2, nothing. It's not possible. In an ATC cabinet, because the switchback is intelligent, it knows that, the monitor knows that the flasher's alive, and the flasher knows that it's getting a signal. It's pushing flash all the way to the flash transfer relays and getting a return back to it because it does load current monitoring. So then, as long as everything's fine, we see these little blue lights on the flasher. But if there's a problem of any type, those lights will go out. And then the monitor and the auxiliary display unit and the controller all know that there's a flasher alarm active because our controllers talk to the monitor intelligently. Can't do that in the TS1 cabinet. Speaking of monitor, this is actually a new slide. This is a as I was thinking about this presentation, it occurred to me that in NEMA TS1, or we had 12 channel cabinets and I think it was 8 channel cabinets. We had different actual types of monitors. Cerebral Tennessee just removed their last 4-phase cabinet that had the monitor with a single round connector. A later TS1 and a NEMA TS2 have monitors where 2 harnesses connect to them. There are also, over the years, we've had different generations and different makes and models of monitors. Peak, Orcs now, EDI, Trafficware, Econolite, fill in the blank, or Reno, A&E, they've all made monitors. So agencies have a hodgepodge of different monitors. Guess what? There's only one monitor for ATC cabinets. It's made by EDI. It's the 2212 monitor. So every agency that invests in ATC has one monitor. With one caveat, there are 2 variants of the 2212 monitor, high voltage and low voltage. 96% of all ATC cabinets ever built are high voltage cabinets. There are some pioneers with low voltage, but every monitor then that an agency like Cerebral Tennessee, Pigeon Forge Tennessee, they have nothing but high voltage cabinets. They have the same monitor for every cabinet. That wasn't the case necessarily with TS1 and TS2. The monitor configuration is programmed on that red data key, meaning that we don't have any jumper boards that could fail anymore, any diode boards. You program the data key, and then that stays with the monitor. Take the monitor out and you change it and put a new monitor in. You put the old data key in. It's that monitor again. So it's very easy to use. I think I'm getting close, Matt. You probably want to get warmed up in a minute. Other improvements for fail-safer design. This is a Scott Evans slide, straight up. That's his phrase. Flasher output monitor. CMU, which means monitoring the flasher system. The second one is my favorite, though. The cabinet monitor unit output override. This means that when the cabinet goes into flash, the monitor tells the switch packs, hey, we're in flash now. I had to make the decision because I saw something I didn't like. Turn off your outputs. So that administratively powers down the switch pack outputs. So if anything happens in the cabinet, like with the main contactor getting stuck, like what used to happen in TS1 and TS2, because that's a mechanical device, it would sit there in an operational state for years, and then all of a sudden the cabinet would go to flash, power down that main contactor, and that moving part wouldn't move. So we find ourselves in a position where the controller was still driving the load switches and driving the signals, and the flasher was also engaged, so it's flashing the signals. So there was multiple indications. It's a real problem. So in an ATC cabinet, the monitor says, hey, we're in flash, and the switch packs say, okay, cool, I'll turn off. So I can't do that. That can't be done in a TS2 cabinet. Compact size and double density. As my uncle had a saying, he said, as technology moves forward, 2 things are supposed to happen. It's supposed to get smaller and more efficient. I want to go back to this slide real quick. In an ATC cabinet, these 2 cabinets I have pictured here, the one on the left is a Caltrans 332 cabinet. 48 inputs, and those are the 2 racks underneath the controller being the top silvery thing. And then 18 outputs, all the load switches at the bottom of the rack. On the ATC cabinet to the right, we have the controller, and then we have 48 inputs, and then we have 16 outputs. So there's 2 less. But we have something called virtual channels, which means I can take unused channel colors and I can AND them together in a 16-channel configuration. So technically, if I had 4 PEDs and a few flashing yellow arrows at that intersection, I could have 20 channels. So I actually have more capacity, and look at all the space that I have available for COM and battery backups and new detection technologies and whatnot. So the idea here is smaller and more efficient. We solved that with ATC. And yes, we have different cabinet shapes and sizes too. State of Maine DOT standardizes on the 350i, as does Virginia DOT, Minnesota, and such, because they say, guess what? We want to deck these cabinets out to the nines. I want to put battery backups in them. I want to put COM. I want to put field monitor units. I want to put camera radar fuse detection that takes up an entire cabinet rack space. Rocky's not paying attention. So we designed a different cabinet shell for each application. And this is very important later on when we talk about spec writing and coming up with standard cabinet layouts, because the core of the cabinet is miniaturized, gives us a lot more real estate for whatever else we put in these cabinets. Because these cabinets really aren't just a big metal box that turns light bulbs on and off anymore. No, this is comm aggregate. This is surveillance. This is or not surveillance. This is CCTV. This is travel time detection. This is, you guys know it. All the things you would see when you walk through ITS or IMSA or an ITE show, and you see all of the cool stuff at all of these booths. We're actually the boring part of the industry at this point, but I still like where I am. An efficiency gain here, true LED signal compatibility. I actually thought about pulling this slide out of the slide deck because I'm sitting here going, man, it's 2025. Who's still running incandescents? And then Matt and I drove down. We drive through Sweetwater, Tennessee and such. It's like, oh my goodness, these are all incandescents. Okay, well, I need to keep this in here. So thing one about ATC cabinets and incandescent lamps. Oh, I muted myself. Somebody muted me? Okay, how about now? Can somebody on the chat? Okay, laugh out loud. I know that dude. Okay, good. Somebody's messing with me. They muted me, or my laptop hates me. One or the other. Can you see it? Am I still sharing? Okay, cool. All right. Where was I? Wait, can I say that out loud? I'm back. Thanks for the warning. All right, share. Good. All right. That must mean that we're getting close to a break time. I only have a few more slides, and then we're going to transition over to Matt Q-Free. So the switch packs are high-density switch packs are 2 load switches in one, and they're designed to only drive LEDs, not incandescents. What that also means is when you're thinking about retrofitting or an intersection, upgrading an intersection, better word, from old NEMA or Caltrans to ATC, look up and make sure you don't have any incandescents, because if you do, the minute you power up that cabinet, you're going to let the sacred smoke out of the switch packs, because the switch packs are not designed to drive that. Now we do have a solution for that. We have a new fused assembly inside of that we offer that will actually protect the switch packs, because if there is an incandescent, that fuse, which is rated at 1 amp at the same rating that the switch packs can't supply more than, that fuse will open up rather than damaging the several $100 switch pack. In addition to not having to solve for incandescence and having more efficient switching technology, we're not making waste heat. Heat is the enemy of all electronics. So load switches are made of aluminum because they generate heat, and the aluminum is wicking. It's a heat sink. So, I mean, they just didn't design a product that said, you know, what's going to be really funny is people are going to put this on a shelf, and then the junior technician is going to accidentally knock that on the senior technician's head who's bent over working on the cabinet. Matt, you're shaking your head. Yep, that happens. Yes. So, by cutting back on waste heat and having higher energy efficiency, battery backup systems become more cost effective, because a battery backup solution can now drive a cabinet a couple more hours, or depending on your battery array configuration, perhaps even days. Question. Chat box. With switchback rating when it's in flasher mode, does it not have a higher current rating? That is correct. When it is in flasher mode, it's using different outputs, and it's 2 amp versus 1 amp. That's a good question. Thanks, Jose. Now we can consider smaller BBS for lesser load. Oh, okay. All right. How about now? Okay. So beating up on LED signal compatibility again. This little chart's just for reference. How far we've come with LED signals over the past 20 years. On the break, we're gonna freeze, and I'm gonna fix that. 25 years ago, LEDs, when they first came out, they cost a heck of a lot of money, and they were drawing 20 amps or 20 watts, excuse me, 20 amps, right? 20 watts of power. And then as we progressed over the years, manufacturing got more and more efficient. By 2020, we were down to 3 watts. I think we're closer to 1 watt now. What we have to do with AC LEDs, though, is we have to put an artificial load on them to satisfy Caltrans still. As you can see, that little blue line, that's the Caltrans minimum load requirement, and that's 6 watts. So the LEDs themselves, up in the signal heads, have a resistor inside of them. Again, heat's the enemy. This is why 48-volt DC is appealing to some people, but honestly, between me, you, the room, and the Zoomers, we have work to do with 48-volt DC as far as the lamps are concerned. Switching technologies, it's there, but we're as an industry, we're watching the lamp manufacturers. So battery backup configurations. I was waiting for it. So ATC cabinets come in high voltage and low voltage variants. Both variants, being more efficient, can actually get more out of their battery backups. And we can also look at green energy solutions or alternative energy solutions. Sparco McCain is working. We have several pilot intersections of solar across the country, and it takes quite a few solar panels actually to drive an entire cabinet. But we have solar BBS solutions that we're piloting, and it's kind of working with DOTs. We have one at FHWA lab somewhere in Arkansas. North Little Rock, Arkansas is looking at a solar deployment. I wanted to put one in Maine until the Maine State Traffic Engineer said, "Hey, let me remind you something. We don't get the sun in winter." I'm like, "Oh yeah, that's a good point." But there are also hydrogen fuel cell, which I'm not a big fan, but I see the value in like wildfire areas like Northern California and other more exotic battery technologies. More inefficiency, use of virtual channels. Like I said, when you have 4 PEDs at an intersection and that channel just uses the green and yellow, or green and red, excuse me. The yellows are never used unless we want to jockey them for something, or use like a flashing yellow arrow compact mode. In ATC cabinets, I can take any unused channel color that's in the cabinet, and I can AND them together, and they become virtual channels 29 through 32. So that allows me, and we were actually going to play with this with these, but we decided to keep this simple. I can take this backpack cabinet, which has 8 channels, But if I'm using 2 PEDs and 1 flashing yellow arrow with protected permissive, I actually have 4 unused colors. So I could create 2 more PEDs, or I could create another full green, yellow, red channel using just unused outputs. So this is something I can't do in NEMA. I can do load switch steering, and I can do some I can repurpose load switch outputs themselves, but I can't run them through the monitor as if it was a complete channel. Now, I can't do this in a 32 channel cabinet because I have 32 physical channels. So I can't make a virtual channel sit on top of a physical channel. Flashing yellow arrow setup. Now, ATC cabinets do not have the strict requirement of compact mode or flashing yellow arrow modes. So we don't necessarily have to stick with flashing yellow arrow mode G or mode H, where we're recycling the PED yellow so we don't have to waste an extra switch pack bay. We can choose. We also don't have to play by the rules of saying, well, this is your flashing. Bless you. This is your flashing yellow arrow overlap, and this is your protected channel. It's got to be 1 and 9 and 3 and 10 and blah blah blah. As EDI and as the monitor manufacturers dictate to us. No, in an ATC cabinet, I can say this channel's my overlap, this channel's my protected, and this channel's my opposing through, and it can be any one of the 32. And then the monitor key just says, okay, cool. We call it the FYA pairs. ATC or the EDI monitor supports up to 8 FYA pairs right now. So I can run an intersection with 8 different flashing yellow arrows, which we're starting to see. We're starting to see FYA right turns and FYA left turns. And let me tell you something, that's a pain in the butt to figure out the preemption routine for that. Complex intersections. And these aren't just like things like diverging diamonds or spuies, but these could be intersections that are 8-phase quad left with 8 flashing yellow arrow and bike lanes, and also maybe a railroad blank out sign. So having more inputs and outputs allows us to take a cabinet and solve for complex intersections. And it's, like I said, it doesn't have to be complex geometry like a diverging diamond. It can be just something that's really busy. So run multiple intersections from a single cabinet, or run complex intersections from a single cabinet. We're looking at the traffic circles. I can't talk anymore. We're looking at the traffic circles in Washington, D.C. right now with ATC cabinets. Here's an example of complex intersection. Lemon Grove, California. Got light rail going right through it. So during limited service or during preemption service, that intersection is cut in half. So I have to run that in the limited service configuration. I can't really, that's going to be super hard to do with multiple cabinets, as you have to tell both cabinets that the rail's there. And typically that preempt input signal comes into only one cabinet. So Lemon Grove, California, this entire intersection, 32 channels, one cabinet. South Portland, Maine, this is closer to home for me. This is all one intersection. This is a screenshot from my cyber cabinet simulator. The intersection, or the vehicle overlaps on the, I'm going to drop an F-bomb before the end of the day. The intersection on the, off to the left, vehicle overlap 4 and vehicle V13 and everything, those are just overlaps being driven from one 32-channel ATC cabinet. And the intersection on the right, that's the intersection of Main and Broadway. 8-phase, 4-PED, luckily, and a couple right turn overlaps. All of that pulls back to one intersection because the controller can run that sequence much more efficiently, or the sequence of those two intersections can run much more efficiently under one controller, because I'm treating the left side intersection just as overlaps. So it's actually, I think that was a 2-ring intersection. And then last but not least, decoupled service assembly. I've had to fix I've had to do field repairs to ATC cabinets before. Things are going to break. I'm never going to tell you that our ATC cabinets are bulletproof. Poor choice of words on this particular slide. That's Fort Worth, Texas. So servicing a cabinet that fails, I can actually power down most of the cabinet and leave flash active, because the flasher system exists, or is is deployed in the service assembly. So that's where my main cabinet circuit breakers are located, my flasher is located, my utility surge arrestor. So if I need to replace a bad output assembly because it took an electrical hit, field short or something, I can actually power down almost the entire cabinet, replace the output assembly while I stay in flash. So I don't have to notify, I don't have to go stand up stop signs or notify police if that's the agency protocol. I can actually stay in flash while I'm doing service on the cabinet. Once we get good at it, it takes 20 minutes to replace an output assembly. So it's really nice to be able to do that in flash, which I did last year in Philadelphia. Okie dokie. Now we're going to segue. I want to pause real quick for ATC cabinet questions before we segue over to controllers. Anybody have any questions? Good. I've got 2 more slides, and then we're going to take a 10-minute break, and then Matt's going to get geared up for to talk Q-free. Yes. Yeah. So yeah, Matt McCain. Yeah, Matt McCain said that that there's an advantage to like the large cabinets, like the 350Is, where that second bay can be a different key. So we have the rack on the left, that's the intersection that's running the intersection, and then a rack on the right with that's keyed with different locks, secured differently. That could be COM or something. So you can actually have different departments or different personnel accessing different parts of the cabinet. So you're making me think of VDOT right now, where VDOT says, I don't want the signal techs to have access to the COM side. So they rekey the right side bay with the COM bay, or they installed another COM cabinet, and then they keep that externally secured. Because let me tell you something about cybersecurity. Physical access is considered a breach of cybersecurity. So no matter how, I mean, that fails an audit immediately. No matter how great of a firewall or encryption or anything like that, if someone can walk into the server room and lay hands on that network switch, boom, that's a failure. All right, good point, Matt. Thank you. So ATC controllers, key concepts. I got one more slide, and then I'm going to shut up. Trust me, for a minute anyway. So number 1, I talked about this earlier. They're built on the standards. All of our controllers that we have here, the Blade, the XN1, the Q-Free, and the Flex, they are all 5201 controllers, version 6. Modern communication interfaces. The first traffic controller I ever saw didn't have an Ethernet port. This was in 2011, and I'm sitting here going, wait, what? They sell these products that don't communicate over Ethernet? What is this industry? So all ATC controllers have to have honest to God, by God, Ethernet ports communicating over good old TCP/IP version 4. They all have to have USB ports. They all have to have synchronous and asynchronous USB ports, or serial ports, excuse me. Asynchronous for communicating with, devices like time clock or GPS clocks and FSK modems and such. With synchronous used to communicate with the cabinet. So this serial cable right here on that blade, that's a synchronous serial port, SDLC. And of course, scalable and future-proof. This is part of my segue. Hardware is designed to be upgradable and customizable to adapt to the needs of the 21st century intersection. Blade, I won't take away from Nikita's presentation, but nailed it. Q-Free and McCain, guess what? We can put new engine boards in here because we can actually upgrade the processors and such in these machines to meet the next generation requirements. So as someone comes out and says, oh, look, we found a new thing that we can put in intersections, put in traffic controllers, ATC controllers, as an industry right now, we're designing these things to be upgradable and future-proof. All right, so let's explore that. And that being said, oh, one more, modern traffic controllers. So this is the last bit, I swear. Number 1, the traffic controller does the most basic thing. It's signal operation. Ah, you bastard. It handles the signal operation. Detector inputs, of course. So detector inputs come into the cabinet, and then the controller activates or makes a decision based on those inputs. Coordination timing, emergency vehicle preemption, and low priority. Data collection and SPM logs, because that's a key requirement in any intelligent transportation system now. Special operations, connected vehicle, and web user interface. Spoiler alert, these all have web user interfaces. So that's kind of the baseline. Now let's explore what else these devices can do. And with that, I vote we take a 10-minute break to fix my PowerPoint, and I'm going to stop sharing. And if you have any questions, please feel free to throw them in the chat log as we're breaking. But it is 9:48, so let's reconvene at 10 o'clock Eastern time, and you guys will have Matt McCain.
Good morning, everyone. Everyone hear me okay? All right, looks like we're good. I'm Matt McCain from Q-Free. Wanted to go over some things with Max Time IC that I actually find pretty interesting, which is really cool about our product, I feel. Let's get started. There we go. One of the key concepts, or three of the key concepts that stand out, are our web UI. Very easy to use. Much better than trying to use the front panel display of the controller. You can also do a transactional save, so you make all your changes and then save it later. Or if you find out, hey, I don't want to save that, I made a mistake, you can undo the changes really easy. And I'll show you that later in the live demo here. You also have the ability to configure or actually load pre-installed databases. So if you're wanting to set up an ATC cabinet and you're like, well, I've never done this before, I don't know the steps that are needed to do this, what modules I need to turn on, we actually have a pre-installed database for that, along with others as well. Config validation. This is handy that if you're programming up the controller and let's say you made a mistake and maybe have the ring structure wrong or your splits don't add up in coordination correctly, the controller is going to tell you that. It's going to show you that in the config validation that, hey, you have something wrong. It's going to give you problems. Biggest thing is if you're ready to upgrade an ATC cabinet to an ATC cabinet, any of the ATC controllers that you have like an ANEMA cabinet will work in an ATC cabinet. Granted, size restriction, but you don't have to go out and buy all new equipment. You can use the existing equipment that you have if it's already ATC compliant. All right, what I'm going to do now is actually bring up the live web UI of this controller, our controller. Function. I hit extend, right? Or duplicate.
So, well, yeah, that one.
You sure?
Yep.
Okay. Let me drag this bar out of the way. Come on. All right, we're just going to stick it up top. There we go. To access the controller, you actually put in the IP address of the controller, and you're going to be presented with a login screen. You put a username and password in just for demonstration purposes, since this isn't out in the field. I set up guest access, so I don't have to log into it every time. So we're going to sign in as guest. Eric, can I move this? Right. Can everyone hear me now? So should I back up, you think, or? Okay. I'm not sure where I lost everyone at with the audio, so I'm going to back up a little bit. I was talking about the tiles earlier, where you can actually add and remove the tiles you want for custom displays. You can add splits, and you have the ability just to move it around to where you want, which is really nice. We're going to go back to controller with the phase configuration, phase timing. And you have the ability to show all the phases, or if you just want to show the ones that are active, you can leave that little tick mark off. You also have the ability to show all parameters, or just the ones that are actually have, most commonly used. But if you were to get down and say, okay, we're going to use max 3, and I put a value in there and save it, if I turn off the show all parameters, it's now going to include max 3 because you've added a value to it. But if I take that and put it back to a 0, it'll disappear. So it just cleans it. It's just neater and cleaner to do, where you don't have to go through all these different options if you're not using them all. The other thing that I like with this is you have a status replay, where you can actually replay the signal back in any certain time. It runs off of the high res data, so it holds about 2 to 3 hours of that data, and after that, of course, it just first in, first out. You have some reports in here: termination, coordination. The detailed event report, this is your actual high res data that's displayed, and you have the ability to actually export this as a database file, which I help out some with the service side of things, getting tickets and for customers. And this has become very helpful when we have some issues that we want to see, hey, what happened in this certain point of the time where, hey, you're telling me it went into preempt, did this. This is very helpful for us, so we can take this file and actually extract it and get the high res data from the controller. So it is very helpful. So if you have a problem in the field with this, you don't want to power off the controller, because then you're going to lose all this data. So it's very important to stick a thumb drive in the controller, come in here, and actually download that file. You have several status screens as well. If you want to see more advanced status. You can also control these actual inputs and outputs. So if I want to manually put a call on vehicle detector 1, I can do that from this screen. Cabinet status. And this is this frame status that Eric was talking about earlier, where you can actually see all the frames communicating with the CMU of the ATC cabinet and the SIU. You even have the ability to see some of the monitor status if it was actually connected up. And let's say, hey, I still like the front panel. I'm more of a front panel guy than actually using the web UI. We actually have an emulator here that will do the same thing as the front panel. Should load here. There we go. So I can also go in here and program the same thing as well. Plan 1. There's all my times. So just user preference on what you rather like better or not. Sure. Okay.
Yeah.
All right.
Something for everyone's awareness. Me again. Something for everyone's awareness. This is a very unique feature in Q-Free Max Time. the ability to actually intelligently communicate with the monitor via Ethernet. All three of these controllers are communicating with the monitor via SDLC, but Matt, Mr. Q-Free, can actually communicate with the monitor via Ethernet. And almost
serial as well for like the 2070
serial as well for the 20
Yes.
says. So this is an emulation of the EDI ECCOM software. Now there is, I don't know why EDI did it this way, but the feature of the Ethernet in these monitors allow for one connection at a time. So if max time is connected to the monitor, then ECCOM will not be able to connect to that monitor via Ethernet. So it is not a bug. It's not a limit. It's not even a limitation. It's just something you need to understand as you implement Q-free controllers and tie them into the EDI monitor. It's very useful to be able, because what can you do with that? You can pull monitor logs.
Mm-hmm.
Just like everything you can do from ECCOM,
you can see the voltages. Yes, everything from
Yeah.
ECCOM.
So very powerful feature. But when someone then says, hey, ECCOM doesn't work anymore, it's because EDI only allows one thing at a time.
Very true. Good point, Eric.
All right.
Thank you.
Silencing myself now.
We have a very robust user programs where you can actually do user logic. Basically, it's so involved that you could actually program up a whole signal just from user logic and not even have to touch any other menus. It's very powerful. We actually have a customer that uses this feature where you have CMU dark channel map. One of the benefits with ATC is you can pull up different dark channel maps for like time of day. And this particular customer has the lanes change direction at different times of the day. So they have signal heads that are dark on one approach, and then when they flip the lane configuration around, that head becomes active. So now they want to actually see, hey, I don't want to see that channel being dark anymore because it's actually active. So that's one thing. It's nice that you can't do with the TS2 cabinet. You would just have to ignore the, that output regardless. But yes, you have plenty of functions in here, and you can actually call other programs. You have a whole bunch of programs you can call. So you can use program 1 to say, okay, if this happens, execute program 2. It's very powerful. I'm quite impressed with it. I've had a lot of experience with a whole bunch of different controllers, and I have to say this has got quite a bit of options with it for that. Administration, this is where we can actually load a default database and also some configuration. So what I'm going to do now is show you how you would bring in a factory template. You have like the ATC 16 channel, Caltrans, NEMA TS1, TS2. And if you want that to be active, just click on set as active, and it will actually load that database at an all red condition. So the signal will never go into flash, assuming you have your monitor programmed right and everything else, and everything's configured correctly. You also have the ability to load multiple user databases. You can see I got 3 different databases in here. So, let's say you may have a contractor working late at night and they want to change the phasing. Maybe they want to split the side street or something. You can actually go in and create a separate database and then load it when they're ready to do construction. So there's some advantage to that as well. You can also download the database. You can upload a database through a thumb drive. There's so much to talk with. It's just not enough time to do it. But there's I could go in more depth, but this is kind of the high level overview of how impressive that I think this is. And of course, with troubleshooting, you have your cabinet status screen like I was showing earlier for your errors, if there's any SDLC errors. You also have like detector status. You'll see if you have any detector alarms as well. Anybody have any? Oh, wait, one thing I did biggest thing I forgot to show. I'm sorry. Let's say I want to make a change. Let's say I want to change the ped clear to 20. And let's say 20 on this one. Yeah. That better? You can either hit Control S on the keyboard and it'll save it right away, or if you click the little disk icon, you can actually see your changes, which you had before. Last value was 18, new value is 20. This one was 0 and it's 20. But let's say, hey, you know what? I didn't mean to type that in there, but I don't want to cancel all my database changes just because of one mess up. You can actually do this little undo button, and it just takes it away and puts it back to 0. And then you can hit save, or you click on revert all changes and it actually undoes everything that's listed here. So we're just going to hit save. And then the other thing I didn't show under the database management is I can actually see a list of changes. Remember, I just changed that ped clear from 18 to 20. It tracks all the changes in this database. And of course, it says changes by guest because I didn't log in. But if I was logged in, it would actually have the user's name that was logged in. But all right, let me do that. Oh, wait, I can't pull those. Oh, okay. What I'm doing is actually unplugging the C12S connector from the controller to cause a COM failure. And if you look at the little bell at the top right corner there, it's actually saying TNF flash response fault. So it's actually seeing there's a fault. And if I don't know why I'm getting a response fault, then I can actually go into status, cabinet status, and go down here, and you see how my total errors are starting to increment up. And it's saying that I had at least 10 errors in the last 10 frames. So you can see that these devices are not communicating. I was about to pull that load switch. I was like, no. Oh, it's not going to pop them? I thought at first it would pop them this year. All right, so you can see that the error stopped counting. Let me make a problem with the config that it doesn't like. The best way, which one to do that? You add a phase and not have a recall on it. It should give you an error as well. We'll save. And phase options. Let me go into detector. I'm trying to get it to where it comes up and gives an error saying a phase enabled, but there's no detectors assigned to it is what I'm trying to do to show you the config check thing. I'm up with a config issue. Well, maybe I'm not going to be able to do that. I'm missing something else here. Enabled. Of course, I don't have it in the ring either, so that might be another reason. All right, well, let's do it with phase 2 instead. Of course, that's going to be a coordinated phase, isn't it? Yeah, I was trying to have it show a config issue. I would think, because I turned the. Oh, okay. All right. It's good thinking. Try that. All right. Guess it won't let me save it, maybe. Oh, yeah, it will.
Program it, but it's not.
Yeah, I would have. Say I don't have a coordination program. If I did, I could do split times and have it.
It is nice to be.
Yeah. Yes. Yes. So rather than try to prove it out, it does work. It's just.
Go over the. Yeah, I know.
Oh, yeah,
That's
without
how
a
to bring it
dwell
live.
phase or something like that.
So, Matt, did you go through the advanced I/O and the modules and explain?
Oh no!
Yes.
I'm glad you pointed
So,
out. I'm sorry.
like on one side of this whole configuration, we have the cabinet plugging into the controller, but on the other side, we got to tell the controller it's plugged into the cabinet. And lovely, these lovely controllers, all three of these actually have C12S for ATC cabinet SIU communication. We also have NEMA port 1, classic, good old-fashioned SDLC for detectors. So,
Thank you. Thank
no
you.
problem.
This screen here, the I/O modules in the controller and advanced I/O, is where you actually configure it and tell the controller what cabinet that it's in. So, if it was in a TS2 cabinet, you would have the terminal facilities turned on instead of the ITS stuff. So you have like terminal facilities 1 and 2, your detectors and stuff like that, and then the small connector. Or if it's a TS1 cabinet, you would have this. So if you didn't want to load a pre-made database, you could actually go in here and actually configure it yourself and convert this existing database to an ATC cabinet. You need your ITS CMU and at least your SIU1. This being a backpack cabinet, we're just using one SIU and are actually sharing the inputs and outputs on there. TS2, you have very limited configuration on a BIU to where, hey, I want to make this an output or an input. With ATC, anything can be an output or input. You can configure it to how you want. So you have a lot more flexibility. Because if that was a TS2, you would have to have a separate BIU for the detector rack and then another BIU for your high density switch packs and stuff like that. And then if to assign the channels, we have channel configuration. You have your little drop down. Assign it to overlap, phase PED, phase vehicle. And then we can actually, you have the ability to remap any of the inputs and outputs. We allow for the user to remap any input and output to what they want. Like here's our outputs and all the load switches and everything. You can remap it. You can even remap it to like an aux function. So if you have a time of day and like a sign comes on, no right turn or railroad or something is active. But yes, there's a lot of flexibility with it.
Can you go back to I/O modules for me?
Sure.
ask for a friend here because
Okay.
I don't understand what the best practice is, but I've never sat through a Q-free max time one IC training. So when you have a mixed mode configuration, so you have an ITS cabinet or ATC cabinet. I hate it. You guys still call it ITS, but I get why. But technically, it's ATC. But what does it look like when you have TS2 BIUs, and how should you arrange your I/O modules? What's the priority here?
It actually doesn't matter which way you have them arranged. You can put them in there any way you want. It's just like if I want to edit the input points of this SIU here, that's module 2. So I need to go over here and make sure I have module 2 selected.
Okay.
So what I'll do is actually add a detector input. So we're going to do TS2 detector rack 1. We're do like our BIU 9. And I'm going to save it. And you should see the other port, the TS2 port, start to flash now on the transmit. So if I go over to my output points, and now if I go to 3, of course it's not programmed, it's not defaulted in there, so you're going to have to
That
program.
would be inputs, wouldn't it? For a detector rack?
Sorry, inputs. My bad. Brain fart. All right, there we go.
Right.
Vehicle detector call 1, 2, whatever.
So the I/O module
I'm sorry, it
arrangement
should be
doesn't
3.
matter. There's no like hierarchy or anything. So you could do you can move the CMU to I/O module 8 and it just doesn't matter.
Nope, it does not matter.
Cool. Okay.
Like I could do here and then do.
How do you turn on frame 0 for or channel color status for TS2 detection? So like there's a lot of detection out there. Polera, well, no, that's bad. No traffic, Polera, Wavetronics, fill in the blank. What GridSmart? Everybody, if the hardware is designed for TS2 SDLC, a lot of the times they want to know the channel color status. So we have the feature in our controllers called MMU or MMU send only mode for McCain or frame 0 or what have you, are sending frame 0 but not expecting a response. So
when you automatically enable one of the DR detector rack BIUs, you'll see in my communication status, I now have a TS2 MMU. So it automatically turns that on to send the color status. I think some of our older previous versions from way back didn't do that.
So
you had to manually add that in there, but it automatically does it.
So a technician who's installing
It's not muted. I just wonder if there the green light's on again. All right. And did everyone hear me?
So my question, oh, there you go. My question is what a technician needs to do to turn on frame 0, and it's just done automatically.
Yes.
Badass.
Yes.
I mean, that's really good.
Good question. I'm glad you asked that. That's a good thing. Because I asked the same thing months ago, but yes. Anything else I'm missing, you think, in general? Oh, I was going to go in and try changing the preamp to see if it.
Load the bare configuration. Yeah, just restate my question. Or like, what's it? Let's get this out of box.
Oh, okay. All right. Yes, let's start from, all right. Before I do that, let me show you the config validation. Finally got one now. Good call on the preamp. no dwell phases or dwell cycles. So it's letting you know you have a preempt enabled, but you have nothing configured for it. So there's a good example for the config validation. When the controller is shipped new, it is going to, hold on, what I'm going to do is reset the user account. So basically we're going to set the controller up like it actually came from a box and just put in the username and everything. So going into the controller itself to the actual settings app, and then accounts and reset accounts. So this doesn't remove max time. It doesn't delete the database. It just removes the actual user that is in the system. So let me share the screen again. Give me 1 second to. All right. So if I type in the IP address, see, I'm not presented with well, first of all, can everybody see this screen before I go? Okay. All right. You're not going to be presented with an actual login yet because you actually have to configure the controller out of the box. Create a local admin account. So we're just going to pick a name. You want an email in here, password. And the reason the phone number and the PIN is in here is where you can actually do a secure front panel access where you can lock it down and use a PIN number to get into it. So nobody can just open the cabinet and make changes. That's why it's asking for that information there. And then we're saying, do we want it to be a local controller profile or a cloud profile? Cloud is using our password manager software. Trying to remember what it's called, but typically you're going to use the controller profile, the local. And then we're going to hit setup. And now you can see that I'm actually logged on with my username. So then once you do that, then you would come in here and load your default database that you want. So we're just going to pretend this is the one that we want. Now it's going to go into Flash because it's not set up for that. Well, actually, we would upload the database first. So you would upload it from the thumb drive with your database you want. Once you upload it, you would set it active. I'm going to set this active. And see, it says waiting to load. And it's not going to load that other database here until it goes to an all red. And if you're trying to load it and it's already in Flash, you just go ahead and do that same process, but just turn the controller off and turn it back on, and it'll load the new database on boot up of the controller. It may have to wait until it gets to 2.6 again, the beginning of the barrier. Or actually, I think it's the end. Should do it after this. Yeah, there we go. Starting to do it. See how it loaded the new database? and then you'd be ready to go ahead and put it in the field. So what we're going to do is switch back to the other one that is active. And it's just warning you, if you're setting this, it's going to lose any pending changes from the other database. And at this point, I'm going to have to power the controller off because it's not going to go to an all red condition because it's in fault. But once I power it off and power it back on, that database will be instantly loaded again. And when our controller's on, you can actually bypass this if you don't want to see the front panel manager. The front panel manager, it's basically to manage the other apps because we also have Max Time Adaptive, we have Max Time CV connected vehicles. So you can actually install multiple apps on this controller. So this allows you to go in from, the field and say, all right, I want to load Max Time, or no, I want to look at connected vehicles. And then you could actually bring up the menu for that. You also have where you configure everything like your the time, utility. If you want to do a factory reset, wipe the controller completely clean and restart and put everything back on it from Linux all the way back up. Program your IP address as well. And go ahead and reset the cabinet here. What button? There it is. All right. And should be off and running. Okay, showing detector fault because I have the TS2 BIU on and nothing's hooked to it. And then, of course, the preempt. Anyone have any questions?
We don't have any.
Okay. All right. Well, then I think I will turn it over to Unix then. Okay. All right. Give us about 5-10 minutes to set up for Unix, and we'll go from there. I appreciate it, everyone.
Okay. And you can, if you don't want to start yet, just unmute.
Okay. All right. Can you hear me? All right. Sounds good. Hello, everyone. Thank you for joining this session today. My name is Nikita Singh, and I'll be talking about our U-Traffic blade. So, our U-Traffic blade is a transportation control platform that goes far beyond just your intersection control. It's a next generation IoT platform for intelligent transportation systems and combines edge computing technology with your traditional advanced transportation controller, building a bridge to future technologies today. It's designed to be user friendly, ensuring a seamless transition into existing traffic management systems, making the transition like hassle free and smoother. So it's certainly a great step forward for agencies who are looking to enhance their transportation systems. Now, you might ask, what sets the Blade controller apart? Blade is designed to excel in three main areas of concerns: edge capability, cybersecurity, and maintainability. Our commitment is to meet the diverse priorities of different teams within the agencies to ensure that every aspect of traffic management is enhanced. So first, let's talk about edge capabilities. Blade has a powerful CPU and comprehensive communication options. So this robust infrastructure supports a wide range of applications, both native and third party, allowing for versatile deployments across different urban settings. So this reduces your total cost of ownership by combining functionality usually provided by different devices in the traffic cabinet. Moving on to cybersecurity. So we recognize that traffic management is part of our critical infrastructure. As such, the security demands today are immense. So Blade is engineered with a zero trust approach to security. And this incorporates different features like account management, authentication, verifications, firewall integrations, and also VPN support. So we are keeping pace with the IT department's needs and the forthcoming ATC cybersecurity standards. And finally, maintainability. The user has access to detailed device data remotely for diagnostics and maintenance. The users can also perform OS updates remotely using the web browser, which is like very user friendly, which I'll show in the live demo later. And we wanted to provide the ability for predictive diagnostics. So not reactive, where the agency has to send a traffic engineer to the field to fix a broken controller, but in fact have the ability to plan any maintenance tasks ahead of time and avoid surprises. Again, I would like to emphasize that security is a top priority. So from the very beginning, while we were coming up with the hardware architecture, this was a priority for us. So the application which controls your intersection, that is CPAC, it runs on a separate engine board. So your heart of the controller, it cannot be accessed through the next external network. And there is a layer of separation between your critical application and the rest of the applications. The other applications run on a different processor than where the engine board hosts the CPAC. So this also means that you can update your controller, like perform OS updates while your intersections continue to run. So you don't have to like bring down your intersection to just update your OS. Another aspect is containerization. So the applications are running in their own isolated, secured environments. So they are not dependent on each other's operating status. So if any one application is affected, then the other applications can continue to run. And then next is secure boot. So only signed software can run on the device. So this means like no third person with a malicious intent can run their own software on this device, making your controller secure. And for the web user interface, we use HTTPS for establishing the connection. So the Blade can acquire certificates and keep them up to date via the SCP protocol. So this is like a simple and effective protocol to keep your connection secure. Then we have the firewall configuration. So you can have different rules on the controller. So this way, only the communication coming in from a trusted source is able to talk with your controllers. Then also, Blade has local user management. So various roles can be assigned to different users. And the goal is that to have the ability eventually to have the single sign-on solution to be integrated into the Blade. So this way, it eliminates the need for any unnecessary like password sharing or creating like different users on each controller installed at the intersection. And and you have access to continuous updates. So that way, the agencies can update their controller at their convenience and have the latest features and also the security enhancements that come along with it. And all the user actions can be attributed or can be logged on the device. So if there is any configuration changes, it can be linked to the username, and this is helpful for auditing purposes. Now, let's look at the different applications that run on the Blade controller. So first is CPAC. So the main role of Blade is traffic control. So we have ensured that the UI is exactly like our other Unix controllers, for example, the M60s. So you don't lose the familiarity of configuring your intersections. You can easily transport YAML files which have the intersection configurations between the controllers, update your CPAC, and all the other features that CPAC allows you to do. And if you are familiar with CPAC from our other controllers, then there is really not much of a difference, and you can have your intersection up in no time. So Blade is compliant with both the NEMA and ATC standards. And CPAC is a powerful tool, and we have been adding more features like front panel logic, which Jay will eventually talk about today. Next is our insights application. So traditionally, for any signal retiming projects, like the traffic engineer has to gather the data like from the controller manually or use any third-party solutions. The time, resources, and energy spent in these activities like are barriers for many agencies to retime their intersections. And with Blade, the engineer has access to real-time, high-resolution SPM data in minutes. The interactive UI enables you to get a quicker analysis of how the intersection is running. So for example, if the data has a lot of like max outs, then it's an indicator that your split parameters have to be looked at. Also, with remote access to the controller, the engineer is not just confined to the cabinet and doesn't have to go through the pain of gathering data manually. So this is a unique feature for traffic engineers right there at the intersection, and it gives you real-time analytical capabilities. And then if the engineer wants to do like a detailed analysis, then we always have our insights application, which could be integrated to our studio solution, which users can use for in-depth analysis, and it has like data like coordination health, pedestrian delay, etc., for example. Next is travel time application. So travel time application gives you analysis of the time taken to travel between two locations. Usually for travel time calculation solutions, it requires the installation of a sensor to detect the vehicles, and then also an additional module in the cabinet to analyze all this data. Or with Blade, all these capabilities, they are built into it. So there is no requirement for adding more devices and managing more devices, making it a very cost-effective solution. Blade comes with an integrated LTE module, and this can be used for fast backhaul connection with the TravelSense app, which is powered by Acyclica. So usually we have our phones with our Wi-Fi and Bluetooth in discoverable mode. So with the help of the Wi-Fi and Bluetooth module in the Blade, it can detect the different devices going through the intersection, and this data is then used for calculating the travel time. Next is communication hub. So this is another feature which we have included to make our users' life easier. So with the help of an embedded managed Ethernet switch and a software VPN client, uTraffic Blade can be used to connect to field devices through a remote network using the VPN protocols. Also, the optional onboard cellular modem can be used in this solution. So this eliminates the need for any additional communication infrastructure. So the users can basically bridge the wired network and the wireless, like the LTE network, and this can allow them to configure their devices as they see fit. So there are like multiple Ethernet ports in the front, and also with an addition, like optionally you can add them in the back as well. So you can create like different interfaces on the device, where like you can have a separate network for connected vehicle. So like for your RSUs, for your connected vehicle data, then you can have one for your central management system, one for just cameras. So this gives you the versatility of configuring your networks and having them isolated from the external network, which makes it secure so that nobody without access can access and get into these networks. Next is advanced diagnostics. So the advanced diagnostic capabilities allow continuous health monitoring and real-time data analysis. So potential issues can be identified before they lead to failures. Our goal is to allow our customers to have proactive maintenance, and we have access to the CAN bus on the controller and can gather different data such as like the device status, the engine board status, CPU utilization by the applications, or the status of the power board. So you can monitor all the status of the applications and verify that they are all running fine. So traffic professionals can access detailed information from any browser, since you have the web user interface, allowing for a very efficient system management without the need for on-site visits. Another feature is like updates on demand. So this is where like as and when we have new OS releases which are published, then the agencies can update their controllers based on their convenience. So we have this system update interface where you can basically check for updates, and if an update is available, it would show up here, and then you can update your controller. So this update happens in parallel while your intersection continues to run. Then next is sensor fusion. So you can connect cameras, for example, like a Bosch smart camera, directly to the controller. So the camera metadata is fed into the controller directly, and it is processed by the blade. And this metadata can be translated into different events. So for example, you can configure vehicle zones and link them to vehicle detections onto the controller, or like for pedestrian zones, you could trigger a pedestrian detector based on the detections coming in from the camera. So this way, like you can identify like even like some cameras, they allow for identifying the type of vehicle as well. So, and in those situations, you can link it to like specific priority calls. And the advantage is like you don't need a separate module to understand the metadata coming in from the camera. So this way, it allows like installing another equipment and like managing that equipment, when all that can be done right in your controller. Also, this smart detection interface, like it can be extended to IO modules as well. So so for example, like you can have a thermometer monitoring your cabinet temperature and then link it to the IO module, and you can get the status of the temperature in real time. So we've been doing quite a lot of testing, like to ensure that all the detections coming in are accurate and we don't miss any of these detections. So this is like a quick lab setup which we have at our office in Austin. So we have like these multiple cameras which are like monitoring this stream coming in on the TV. So, and we've configured it to put in as different detections. So this is basically stress testing the detections to analyze, like to make sure that we are not missing any data coming in from the camera. Here is an example like of how it would look in the Bosch interface. So here you would have like different zones configured on the lane, and then each lane is attributed a specific is identifier. So like you have lane 1, lane 2, lane 3, and these zones can be then added into the controller, and you can link it to the vehicle detectors. And this is a screenshot from the Blade controller. So this is how you would configure your camera. So you have different settings, like basically put in your details to connect to your camera, your IP, username, password. Then you have zone configuration. That's where you would put in the lanes which we saw, and then map it to the different detectors here. And also you have the ability to get a live video stream. So that way you can see, you don't need to like log into the camera to get a live feed of how the viewing angle is. So you can see that through Blade itself. Now let's get into the live demo. So here I've you can't see it. Screen. Okay. Let's try it again. You see this?
Now you can't see it over there, can you?
Yeah. I wanted to duplicate it.
Do a duplicate, duplicate your screen.
Yeah.
Stop sharing for a second, duplicate.
And
then
reshare.
Yeah.
Okay. Yeah.
So we had to make that.
Okay. New share. Okay. Okay.
Are there any questions in the chat, Eric? I have a few, but I'm gonna wait until after the demo.
Mm.
Oh, look, it's me.
Okay, it's asking me to share here. Okay.
It turned off your Teams, right?
Yeah, I closed it out.
That's happened to me before.
Okay. So here I'm logging into our controller, which is in our lab in Austin. So the way you would log into your controller is like basically put in the IP address, and then it would it would pull up this screen. So this is the account management screen where you would have to put in your username and password. But by default, you would be able to see the status of the controller. So this is the home page. So here, this is a preview of the phase status. This is a, like the 111 screen on CPAC. And if there are any faults with your detectors, that would show up here. This is your device info. So it's like tells you what CPAC version you're running, the last when the CPAC was the version was updated. Then your Linux kernel version, your uptime, and your release version. So this is your OS version, which is hosting all the different applications. Next, you have the applications tab. So since we are not authorized user currently, so you just see CPAC and the other applications are hidden. Then you have your phase status. So this is tells you, gives you a phase status. So it will show like your countdown, your phase calls, your pet calls, all those data can be seen here. And based on the phases you've activated, you would be able to see those phases here. Next is detector status. So for detector status screen, this will show like if there are any vehicle detections coming into the controller, then you would be able to see that for vehicle detections like pet detectors, preempt detectors, or special detectors. And this is like the detector configuration details which would show up here. Right now, I don't have any detections coming in, so that's why you don't see any inputs here. Next is, so let me log in. So I've logged in as an admin user here. So that's why I am able to see this settings page as well. So only admins would be able to make any change any configurations on the controller, settings like IP settings and those kind of details. So this is the USB screen. So this is if you would want to update your CPAC, update your YAML files, then you can plug in your USB, copy to CPAC, and then go to CPAC and use the regular process for updating. Next is the diagnostics. So here we have the controller status. So in this page, you will be able to download logs. So you can download logs, which has, this is the application processor logs, and this is the CPAC logs. So this would have like perflock logs and those details. And if you have a USB connector, then you will be able to choose this option, or you could directly download it onto your laptop through the browser.
Can you expand each one of those one at a time? I'd like to take that in for a second. Device and services and whatnot. I'd like to see the data points.
Yeah, this is something which we are still not like hard defined. Like these are the stats coming in. So this is a first pass of what we want to look it to look like.
This is extremely powerful though, because you have under the hood look at each part of what's inside of that blade controller.
Yeah.
So device is the operating system, not CPAC, but the entire user interface and all of the apps that you've shown. Now this is the Linux kernel that's driving that and RAM and all that stuff. But then you can then compartmentalize. One of the challenges we have in the industry with troubleshooting traffic controllers is we don't know if the connector box has failed, or 24-volt feed to the connector box has failed. We don't have a good data point for that. So now, as just humor me, expand field IO board, please. So there's all of our statuses for our of our ABC connector box. So in a NEMA TS1 cabinet or an ATC cabinet, we lose 5 volt or 24 volt or anything. This is a know before you go kind of screen where you could log into the controller that you know is in flash, and then the technician can say, "Oh, it's got a 24 volt fault. I know that that it probably took a lightning hit, and I'm going to need to definitely take a controller with me versus play on-site troubleshooting." Like I said earlier, $400 to roll a truck that's the average soft cost of dispatching a technician. So having the ability to hit this from your VPN or your TMC or whatever is critically valuable. Sorry, I don't mean to hijack, but you know I'm excited.
No, yeah, definitely is very useful because then you can schedule your maintenance and avoid any last minute surprises. So this was the diagnostics part. Then let's take a look at the applications. So we have CPAC here. So this is your usual CPAC interface, and you can like navigate through it like using your keypad, how you would do it on the front panel. Next is insights application. So with this, basically you can get your split monitoring data, and you can see this is the live data which is coming in. So you have a key here, so like you can see like gap outs, max outs, force off, and you can see the different cycles here, which is very useful, and you can always like move around and see go back in time. Also, there's an option like to get custom data, so you can go up to a week behind of data and get the face data here on the controller itself. And if you have different like time of day plans, then you can choose and filter out the different plans, and it will show like the actual plan split configuration, and then you can see the historical data here and the live data running at the intersection.
I have a question, another question. Make sure I'm on. Yeah. So this is like a visual measure of effectiveness report, and also it's using high-res data, right?
Mm-hmm.
I don't have that. I'll just admit, I'll follow my sword right now and say I don't have something like this. This is cool as crap. Matt, does MaxTime have a visual MOE? Okay. Is it using high-res or okay? So this is very cool because it's a visual high-res or is a visual report using high-res data.
Yeah. This is insights module. Then we have travel sense application. So this is basically your travel time monitoring. So and you can configure it, like you can enable it and have like Wi-Fi, Bluetooth monitoring on, and then enable it to send this data to the backend and get the travel time statistics. Next is sensor fusion. So this is where you would interface with the smart cameras. So here you have the settings page where you can enable this, and you can add the camera list. So you can add the list of all the cameras. So for example, you have camera for each approach, then you can add all these cameras here. So you can just go edit, add camera, so and update. So that way you can, if there are any new camera installations, you could update this on your controller. And then for each camera, you have a configuration and the configuration page for each camera. So this is like settings. This is where you would enable it. You would have your video stream, assign its IP and password. And then next is zone configuration. So here you would basically the zones which we saw on the camera, so that would show up, that you would add here. So you can add new zones, so and update it. Next is detector assignment. So in this page, you can link each zone to a specific detector. So here you can also extend the duration of call on the detector, and you can configure for how long you want to extend the call. And then this is where you would select your detectors, and if you have, and you can basically select the zones which you want to link to the detectors. Next is the video stream. So it's foggy in Austin today. So this is a camera in our Austin parking lot. So this would be your live stream of the camera. So this way you get an understanding of how the view angle of the camera, and just it helps in basically calibration and configuration when you want to identify the zones correctly. The next application is like the LT module. So right now there's no LT configured on this controller, so that's why you wouldn't see much. But yeah, you can just edit, turn it on. If you have any APN details, you can put it in and configure your network. So these were the applications, and the next is settings page. So this is the first is like Wi-Fi settings. This is basically you can enable your Wi-Fi for a specific duration of time. So like you don't have to get, you're by the controller, you can pull up the controller screen on your iPad, your phone, your laptop. You don't need to open the like use the front panel as such. And there's a timeout, so that way if you forget to disconnect it, it disables by itself. Then this is your NTCP port configuration. There you can put in your custom, if you have a specific requirement for your UDP TCP ports, you could configure that here. So this is network settings, which is our communication hub. So here you would see by default, you would have these 4 devices. So this basically is each Ethernet port on the front of the controller. So, and then you can disable or so I know that some agency had the requirement like where they want to disable the ports. So you can disable specific ports, and you can also create bridge interfaces. So you can bridge like just these 2 ports, or you could have all the ports bridged. So this default bridge is where you have all the 4 ports bridged together, and you can edit the ports you want in it. So you can just select on the ports you want to bridge and create new bridges for this network. And then we have interfaces. So this is where like you can configure different networks. So for example, by default it's like static and DHCP. So here you would choose your devices. So you could either choose a bridge device or like a specific port, and then assign a static IP address, the gateway, and then also the DHCP. If you want to prioritize the gateway through DHCP, you can choose that option. Also, Blade can act as a DHCP server. So you can enable this option, and that way the different ports can assign IPs to the devices you connect to it. So And you can add different interfaces. So you can create new interfaces like just purely DHCP or like just purely static. So all permutation combinations could be done. And you can see the your status of your interfaces here. So for example, if there's no Ethernet cable connected, then it would show down here. So that way you can identify, hey, something like it's not able, you're not able to talk because it's the interface is not up. Next is unit settings. So this is your device configuration, like you can give a specific identifier. Then this is your intersection. Yeah, this is your the device name. So for peer-to-peer communications, like you would need the device name so that you can configure it through here. And then the date and time settings. So for configuration time, this is your OS update. So you can see the current OS version running here, the last time it was updated, and you can check for any new updates. If it's available, then it would show up and you can choose to update. This next section is the user management. So here, basically you can create different users. Only an admin user can create these users. And you can assign different groups like app user. So an app user would be able to see all the different apps, but won't be able to make any setting changes. Anonymous would basically have very limited access to the controller and just CPAC configuration. So yeah, that was about our user configuration. And that brings me to the end of my live demo. Next is okay. So just summarizing all the key points for uTraffic Blade. So you can see that like Blade provides a vantage point of intersection. So you can get intersection status, power and environmental status of the controller, then signal performance reports, and a lot more. And all these features are easily accessible to the user. The expandable interface supports plugin applications. So for today's and tomorrow's technology needs, you have the architecture infrastructure available. And on top of CPAC, to control the intersection, user can access more applications like we saw. And it is a plugin, like the architecture allows you to plug in more applications based on the requirements. And the best part is it's all available at your fingertips. So the web browser interface or the Wi-Fi capabilities allows engineers to connect to the controller remotely. So the intersections of today are becoming more and more complex, and it requires installation of devices both inside and outside of the cabinet. And this is required for managing advanced traffic and transportation systems. And Blade combines all these features into one unit, and it's a compact device. So it's very suitable for small cabinets or large cabinets, and also it can be shelf and rack mounted, and it's compliant with the NEMA and ATC standards. And there is full support for cyber security measures. So like the user management, the firewall configurations, the communication hub, all allow to make your controller safe. Next is power supply. So continuous power to your critical devices such as transportation control, traffic controllers and signals is very critical. And power redundancy ensures that your critical devices continue to run even though there is component failure. So blade comes with a hot swappable power device. So that way your intersections can continue to run. If one fails, then the other can other one is available as a backup. So the blade is basically engineered to withstand like harsh environmental conditions. This ensures like there is a high mean time between failures, and the advanced diagnostic capabilities help the engineers to monitor their controllers remotely and schedule any maintenance tasks. So to summarize, blade is built as reliable as it is innovative, and allowing users to manage their intersections like more straightforward and a cost-effective way. So this brings me to the end of my presentation. Are there any questions?
Thank you, Nikita. That was fantastic, actually. And it's a well, full disclosure. In the 6 months I worked at Unix, I was part of the Blade project, and this is an impressive device for the 21st century. Again, with the ATC cabinet being the first cabinet platform designed in the 21st century. The Blade opening the door of dual processor, dual OS control, and having all of these other functions, and you literally could reboot the controller and keep CPAC running, because CPAC is a different board inside of this unit. So this is no offense, but like light years ahead of an M60. Even the power supplies, they do not have an interconnecting harness anymore. It's a very positive termination. So like this is an impressive platform, and it is a wonderful revolution for us to see happen. I'm kind of jealous, honestly, because we have to work hard or we, Swarcom and everybody, we have to work hard to pick up the ideas that are already running inside that unit. So lunch is here. Segue. Lunch is here, and I think we're gonna take an hour. Is that right? So what time is it? 11:30. It's 11:30 on the dot. Well done. So we will meet up at 12:30 Eastern time again, and then we're gonna pick up with Jay from Unix, talking about CPAC, kind of going through an out-of-box and interconnection with ATC cabinets and such. Yeah, that's all I got. So, all right. Thanks, everyone. We'll see you in an hour.
Hello, everyone. My name is Jay with Unix Traffic. Can you hear me? I'll be talking about CPAC out of the box, on how to program CPAC with ATC controllers or cabinets. So CPAC is the Unix intersection control software. Is compatible with ATC 5301 version 2.2 cabinet standard. Our firmware, we have a single firmware that runs on all our controllers and is compatible with all cabinets. We recommend using CPAC 5.5 for the blade controllers with the ATC cabinet because the diagnostic feature we have in 5.5. This is the display screen that you'll see from the main menu. We have a 16-line display where you see the statuses in the bottom 8, and then the main menu, the top 8. You can see at the top the CPAC version that's running. So this one that I screenshotted was 5.4.4 version from March 2023. On the left side here, you see the ring statuses. You see the timers, the min and max counting down. You can see the yellow and red timers, and when the phase maxes out or forces off or gaps out. In the top green box is where you see what bank we're in. So if we're in phase bank 1, so the first number is what phase bank we're in. The second one is what priority bank we're using, and then 3 is the unit bank, and 4 is system bank. So a lot of our programs are bankable. And then the right red box is the phase status. Shows if the phase is on, next, has a call, vehicle calls, PED calls, recalls. You can also see if the phase is being omitted or being held. And then at the bottom green box is where you see the coordination status, the current plan that's running, and the local timer that's counting down. To navigate the screen is pretty simple. The directional keys to go up, down, left, right. If you ever do run into problems or you're not sure what a specific function does, you could press the plus button. It tells you what you're programming. So there's that. The minus button is where you could toggle through the different banks. And then pressing enter is how you confirm programming. And then you could press escape or F to cancel or go back. If you do ever get stuck on a screen and you're not sure where you are, you could press the escape button 4 times and you'll always be back to the main menu. So first steps when you take out the controller out of the box. The first thing you should do is go to the utilities and load default screen, where you'll configure what type of cabinet you're using. So here we'd use ATC cabinet mode. On the screenshots showing FIO, but that needs to be changed to ATC when you're running ATC cabinets. And other controllers we have, the IP address and the intersection ID can be set through the utility screen. But with the blade, that function can be done through the user interface that the blade has. The next step you should do is install any other software like IO maps that is specific to the intersection. The next step is to configure the ITS configuration. So you go to the 4.7 screen, and here on the right is where what you'll see on the 4.7 screen, and enter 115, and then you get to choose either the 16 channel or 32 channel output format, and you can only select one, the 16 channel or the 32 channel. For the input assembly, all input assemblies may be used at the same time. However, CPAC does not provide this ability to use input from assembly number 5, and we could only use 4 partially. When an input assembly is defined as active but is not functionally present in the ATC cabinet, the result will be the cabinet diagnostic flash. So besides all that, everything else is basically the same when it comes to programming with other cabinets. You can go to phase menu, which is 3 from main menu, and then you can start putting in the vehicle data, where you put the vehicle times, min green, max green, passage time, max 1, 2, and the recalls, and then program all the PED data, and then you want to initialize the phases that you're using to either have no initialization or inactive if you wanted to start red, yellow, and green, and etc. And then in the 3.5 screen, phase miscellaneous is where you can program the locking memory, the dual entry, and other miscellaneous options. In the menu 3.6 screen, that's where you can put omits in the omit calls. And then most of this data, except for the phase initialization, is bankable. So you can press through the minus key, and you can use time of day to have different times programmed throughout the day. And then next, you want to set up your ring structure and your sequences. You can have up to 4 rings. You want to configure all your phases, remove any phases that's not being used. You can, at the bottom here, you can see what ring that phase is in. So if you put 0 there, then that phase gets disabled. But you want to make sure that you have a ring assigned and the next phase assigned, and the compatibilities. If you exit and CPAC doesn't like how the ring and barrier is set up, then it will give you an error, and you'll get a chance to go back and see what you did wrong there. Next, you can set up your overlaps. Here on the 4.3 screen, you could set the different type of overlaps that you'll be using. On the screen here, we just have the standard overlaps that we're using, but your flashing yellow arrow overlaps and all the different other types of overlaps that you'll need for PED overlaps, stuff like that. And then once inside, you click into each overlap, you can program the overlap timing. So if you want to add a trail green, or and if you have a trail green, then you could set an additional yellow and red time for the overlaps. Next, you can set up your detectors in the 3.7 screen. Here you can see the detector 1 being programmed with phase 1. You want to make sure that there's a 1 on the call, or you won't place a call on that phase. And then, yeah, volume for counting, and pass to make sure that additional calls are being placed there. If you want to program the detector diagnostics, you can do that in the 931 screen. And there's two banks that you can use and set that up in the time of day if you want to switch back for the different time, detector diagnostics you want to set up. Then you want to set up the output mapping. Here's the output mapping display. You can use all 32 outputs to any control function or source group. The source groups here displayed are phases 1 through 16, heads 1 through 16, overlaps 1 through 16, phase status 1 through 16, and then preempts 1 through 12. You can use the hotkeys to navigate faster through to the different control functions. If you press 3, it'll put you straight into the overlap. And then you can press the up arrow screen when you're at 1, and then you'll be able to scroll through the different load switches quicker. And then you could press E to toggle between the load switch and pin modes. Once you're in the output mapping screen, you could also press D to display the compatibilities. Here it displays all the channel compatibilities the CME should have. So here in this example, load switch 2 is compatible with load switch 5, 6 and 7, and 9 and 11. But yeah, there's the menu where you can see the compatibilities. So in 5.6, we introduced a new feature in CPAC, which is pretty cool. Most of my time with Unix, I was working on the BRT project, bus rapid transit system. We needed an IO map that we had to create from CPAC Logic Builder. It's our separate program that we use to develop IO maps. Now we have the front panel logic where that can all be programmed from the front panel. So it's pretty neat because now you can see exactly what's programmed in there, because once you install an IO map onto a controller, you can't really see what's really been programmed. So this is a pretty neat feature that we have. Yeah, these may be saved and loaded to YAML configuration files on USB stick or uploaded and downloaded via NTCIP by Studio Explorer. And if you want, you could just load the logic file in the YAML version. The logic may be performed both just before and after the 10-second traffic calculation. So here's a step-by-step on how the logic is being read. So it starts with the field IO, and then legacy IO map, and then the peer-to-peer message is read, and then the front panel logic pre-process map, and then front panel logic post-process map, and then the output map, and then the legacy IO map is read the second time, and then the field IO is read. You can have up to 128 steps for both the pre-process and the post-process. And then you can also add a description for each line, up to 29 characters in Studio Explorer. You can't put the description from the front panel, but you can do it through Studio Explorer. You can also open up the YAML file and do it in the YAML, but that's not recommended unless you really know what you're doing. All cabinet input and outputs are accessible. Logic maps have access to all physical and virtual cabinet IOs. I/O is at the logical level rather than the connector and pin level for user simplicity. The I/O is cabinet agnostic, so a single logic map may be deployed across all cabinet types. The I/O, the front panel logic can also be integrated with the peer-to-peer messaging. And it's also bankable, so you can store it in the different banks. And you could enable them through special functions at time of day. So here's an example that, oops. Yeah, so here's an example that we, oh, whoops. This slide didn't get updated, but yeah, in Miami, we had to create some I/O maps to do some logic-based processes for busways. We had preempt and priority buses that needed to detect as a different type of bus during certain conditions. So if video detection failed, or if we were already in the process of bringing the rail gates down, we had to make sure that the calls were being redirected by a different to a different detector to call it to either extend the busway green, or to if the video detection had failed, we would need to abort the gate operation, or service the bus as without the rail gates. So that's something that we can now do through the front panel logic, which is pretty neat. That's it. Any questions? What's the question? No. Sorry, I'm not understanding the question. Load the up IO map is oh no, you still do need to load the IO maps with 5.6. The IO map and the front panel logic are separate, but you could program whatever is now mapped through to the front panel logic now, so you could see exactly what's been programmed.
All right, is this thing on? Oh. Andrew says thank you, by the way, Jay. Okay, everybody, it's me again. Sparko McCain guy. I'm going to bring it home on this vendor showcase, and then we're going to talk about deployment experience with ATC cabinets, kind of tying everything back together. This session was scheduled for to end at 3:30 Eastern Standard Time. I'm thinking we're going to end a little earlier, which I'm sure is going to break everybody's heart here. I don't know about you, but I'm kind of getting the feeling of information overload. So we're going to we're going to be light and not get with the not get in too heavy with the next part. So this is my this is the Sparkle McCain controller showcase, and and talking about Omni. And what I really want to do here is not just repeat everything that Matt and Nikita and Jay said. So I'm only gonna, you know, our traffic controllers are more similar than they are different as far as intersection operation. There are some unique features that our user bases love. But for the sake of talking about ATC cabinet integration, I'm going to move quickly here. But please continue to put questions or comments in the chat. Make fun of me for saying if you want, and then let's keep going. Shut up, Matt. Okay, my controllers, Sparkle McCain controllers. The ATC Flex series is what we brought here today. This is a ATC 5201 compliant controller. Just like the Unix display, 16 lines, except unlike the Unix display, our menus are on the bottom and not the top. This particular unit is an integrated unit with all necessary I/O and SDLC ports for Caltrans and for ATC cabinet operation. But we do have a NEMA version of this Flex that has a connector box. So it doesn't have the Caltrans connections. It has the ABC, ABCD, or A2 for TS2 type 1. And then we actually build connector boxes with manufacturer-specific D connectors. So when you want to do a retrofit in your TS1 cabinet, and you have an Eagle or EPAC DB37, well, DC37 according to an engineer who yelled at me for saying that, or a Traconex or Caltrans D connector, we have a connector box that mates to that connector. All of our Flexes have 15-pin SDLC ports for TS2, and of course front panel USB and Ethernet ports, ATC standard stuff. And it's so nice to have fixed this presentation where it doesn't run away from me like the morning session did. So that's all well and good. We've had the Flex since the late teens. So now we're actually developing. It's time for me to show some of my stuff off. Our next controller, we call it the Flex 2. And I see my branding is incorrect. There should have been a lowercase e on the word Flex. Whoops. It is in active development. It should be available Q4 2025. The actual engineering salespeople told me Q3. So I'm doing the Scotty thing, you know. I'm overestimating. This is going to be another ATC 5201 compliant controller, future-proof design, supporting new engine boards and new internal hardware. The controller platform will support all cabinet types. However, we'll still have the NEMA connector box versus the Caltrans. We're not going to be able to connect a controller that has all of that has every single type of cabinet integration, because you're going to not want to use a NEMA connector box in a Caltrans cabinet and such. Some agencies do. It's weird. We're going to support the modern innovations. Yeah, I know you beat me to it here, buddy. Such as touchscreens, cell modems, onboard GPS, Wi-Fi, that kind of stuff. This is in active development right now. Like I said, later this year. We actually have already sent some of these units off for state approval, QPL approval, and a few states. And it's designed to run Omni EX and third-party applications. Interoperability is a top priority. So exciting! We're going to have a new controller later this year. We're also going to have a new feature that brings it home to the ATC cabinet. I told you guys this morning that the ATC cabinets are capable of monitoring channel voltage and load current. So the goal of the ATC cabinet was for the controller to monitor current consumption and the controller to know when there's a dark signal, but not put it in flash. So we are in our next feature of Omni, released later this year, summer. Actually, I have the beta running on my ATC cabinet in my house. You guys see it on screen. We have a load current or lamp out monitoring feature. The controller will just monitor the outputs of green, yellow, red for all of the active channels, and it'll trend that data. So if it's burning, 100 milliamp or 300 milliamp for a week, and all of a sudden it starts burning 200 milliamp, and it consistently changes, that's a fault, because the controller then assumes that one of the lamps in the street went out. So then that logs that fault. It's a non-critical fault, and then that can be reported back to central, pulled via NTCIP. This helps complete the story of the ATC cabinet lamp out lamp out monitoring features. This is better for us in the industry, us professionals and technicians, because you'll get a report from central saying, hey, lamps out, versus getting the call from the mayor saying, there's a red light out in the middle of the street. So those are the two features I wanted to kind of highlight. I spent all the morning talking about ATC cabinets, so I'm going light on the controller side here. I do want to talk the Omni EX intersection software, the basics. It is an NTCIP compliant software, all-inclusive, single firmware that runs on all Swarco McCain controllers. And actually, I should have updated this slide. It does support it. It is being installed on third-party controllers as well. So it supports being installed on third-party controllers. It supports being connected to third-party central systems. Our built-in logic package is 64 logic gates. Jay, you beat me. You said you had 100, right? 128. And Matt, you have how many logic? I call them logic gates, but okay. So max time is 10 or 12 programs, 64 steps. Jay has 128. So we're all kind of the same. The fact of the matter is we all have logic, and that's really nice. So we can do things at intersections that engineers and technicians dream of, that our software developers haven't coded into the core application yet. So that's super fun. And of course, built-in web user interface. Like I said this morning, all of these controllers here have a built-in web user interface. Omni main status display, just like, well, it's the opposite of CPAC. Our status is on the top, and the menus are on the bottom. What's odd, and I don't know, the chicken or the egg here, but if this presentation is going to be a take-home version. So I think this is the first time I put a CPAC screenshot and an Omni screenshot on the same screen. And for the life of me, I have no idea when I made the screenshot why I left all my detector faults and PED faults on, because that's a dumb screenshot. But I remember that Wednesday when I did this, I was preparing for a presentation or for a user group in Iowa following week. But when you look at our O/N and vehicle and PED and overlap, it looks exactly like CPAC. Again, our controllers are more alike than they're different when it comes to the core software operation, or the core status screens and everything. There's only so many ways we can say, hey, the light's green and there's a call on phase 2. Programming in Omni, directional keypads, moving a cursor and such, very much like CPAC, very much like Q-Free. There's only so many ways you can punch in a min green, 5-second min green, highlight the field, hit 5, done. And one thing we do different is we follow the NTCIP 1201 database transaction process. So as you're going and editing data inside the controller, the changes you made are not committed to running configuration automatically. So you can program an entire page of phase times and pedestrian times and whatever, and then the minute that you're ready to commit, that you verified it, that you punched in everything correctly, and you're ready to step away from the cabinet and watch this run on the street, you can say enter and yes, commit that data at that point, and then the controller loads that new configuration automatically And then you can watch your new PED time cycle and such, or coordination times and whatnot. First steps in setting up the controller, just like CPAC, just like max time, you either load a default database or you load the controller database itself. So in Omni, I have the ability to reinitialize the entire database or just the cabinet IO map. So if I'm doing a conversion, maybe I go from TS1 to ATC, I can keep all the coordination and time of day and everything in there and say, all right, you're no longer going to use ABCD IO. You're going to use ATC. Okay, I can do that without having to punch everything in there. Set the intersection ID that basically name the intersection, same as max time. Set up your in menu 1 your global startup and global parameters, any IO mapping, any BIU and SIU configuration. So this is kind of explains the database initialization, either a full initialization or, like I said, cabinet IO only. Channel setup, where I tell the cabinet, where I tell Omni what each of the cabinet channels or load switches or load bays or whatever you want to call them, the personality or the function of each of those channels. Menu 2 is phase timings. I set program phase timings, phase options, sequences, which phases are enabled and which phases can work with each other. I can do all of that at once and then say enter and yes to commit all that timing at the same time. So one big transaction. And then I configure my overlaps, normal overlaps, flashing LOR overlaps, it includes and excludes for pedestrian phases, pedestrian walks, head overlaps, overlap timing, and I can choose whether an overlap is actuated or not. So I even have the ability to have an overlap be programmed, but not be called unless there's a detection. Detector setup. Again, we set up our detectors to delay or extensions, whether it's a call, passage, or out initial time. Red light protection. I'd like to talk about that later this year. I'm trying to get a spot at Tennessee ITE in Gatlinburg to talk about red light protect. We all have this feature in our controller that is a red extension of some sort. So when a detector turns on, that detector has the personality assigned to it, or strategically that detector has been set at the intersection that it will only turn on if someone's about to run the red light. And there's a lot more to unpack from that statement, but the way this works in all of our controllers is if that detector turns on at the exact moment, the controller assumes somebody's about to run the red light, so it locks the intersection down until that detection clears. The way it works in Omni is it jacks up the red extension time, adds more time to let that person get out of the way. Yeah, it might screw with coordination, but so will a T-bone. And then communication summary. Serial port configuration, which is the asynchronous serial ports, the Ethernet, oh, wrong controller, old habit. The Ethernet interface, the Ethernet 1 and Ethernet 2. Yeah, I know, I'm not your friend. No, just kidding. You configure both Ethernet 1 and Ethernet 2. Timeout, network time protocols settings, so controllers can actually set time from another controller or another network time source. I was kind of impressed that this thing supports IPv6. Do you have IPv6 support yet? We have it under the hood, but it's not ready for use yet. I haven't seen anybody even ask to use IP version 6 in intelligent transportation, but sooner or later we're going to have to. The world's running out of IP addresses. 192.168.88.5 is or 88.0. We just keep using that one all over the story there. Okay, so back to ATC cabinets. I ran through that really quick because you guys are probably tired of hearing about traffic controllers, and they're all great products. But like, it's also 1:30 in the afternoon, and it's like, okay, enough. So the last part I want to touch on, because this is primarily an ATC cabinet session, is what to do after you program the traffic controller. So I've got McCain, or I got the flex all ready. I've got the Q-free ready to rock and roll. I've got the blade ready to rock and roll. Let's plug it into the cabinet. What do we do next? Not you. Cabinet monitor unit has to be programmed. The controller is ready to drive all the outputs. Now we have to program the failsafe, or in this case, of the ATC cabinet, the second controller that actually operates the switchbacks and manages the switchbacks. So not only is this a conflict monitor of yesteryear, but this is an intelligent device that is in charge of communicating with other devices in the cabinet. So we program the monitor with this data key. We in NEMA, we solder a jumper board and we say these channels can work together by installing a piece of copper or aluminum or little twisty wires that fail in 6 months. In the Caltrans world, we cut diodes saying these phases or these movements can work together. In the newer Caltrans monitors, they have this same red data key, so they got away from a diode board, which is kind of cool because it's a software programming. In the ATC cabinet, where's my DeLorean bag? In the ATC cabinet, this red data key is the only way to program the monitor. It's really simple. After the data key is programmed, you take it, you put it in the monitor, you lock it, boom, monitor reads the configuration, it takes off. No other configurable part of this. So the technicians, when they're swapping monitors or anything, the only thing they need to do is put the data key in and lock it. So it's a piece of cake. Swapping a NEMA monitor can take 20 minutes because you take the diode or take the jumper card out. You have to reprogram it by hand, or if it's the dip switch kind, you got to flip all the dip switches, all these things. In an ATC cabinet, it's just a matter of changing out the little Fisher-Price data key. Just kidding, it's not made by Fisher-Price. That's the first time I provided tech support for an ATC cabinet was a police officer, and I said, you got to reset the cabinet. He's like, what do I do? Where's the reset button in this thing? I said, you see that little Fisher-Price data key? Yeah, there's a button next to it. This is the only reset button that matters in an ATC cabinet. So the monitor itself cannot program the data key. EDI purposely built this key slot to be read-only. Good idea, because we don't need jokers remotely reprogramming the monitors. So the way you program the data key is with this little monitor key box available from EDI. It's their product. All ATC cabinet vendors, or you can buy them. You can procure them directly from EDI or from an ATC cabinet vendor. So the technician or the engineer has that little key box, and then they use this software called Monitor Key. Use to configure the data key. You can read and write to the data key with that little box. And I have an error on this slide. Monitor Key software and the USB driver need to be installed. Free download from EDI. The box costs money. The software doesn't, which means a signal shop or an engineering shop can have a couple of these boxes and then that software installed on 20 laptops, and you know it shares around. So the Monitor Key software, I did fix this slide, allows you to do the following: create new data key configurations, save the existing configurations, or save a good configuration to the key or to your file system, so you can create an archive of your field of your monitor key files. Print if you want to waste the paper, but you can also, of course, build them with the software. The software includes a setup wizard. First time you use Monitor Key, it's a little intimidating. And then the second time, after you've realized that there's a setup wizard, you run through the setup wizard and it solves for 80% of the configuration in 6 little screens. And then there's a parameter check wizard to make sure that you didn't make a mistake, because this is the safety device of first and foremost. And then, of course, you can read and write to the data key. This is a very condensed version of a 4-hour training I did in Minnesota in 21. So managing the data key files. I don't like this slide. Programming procedure. Nope, wrong slide. This is the one I want. Okay, start with a setup wizard. That previous slide I actually argued with Scott Evans about, because I'm like, I don't like this. He's like, no, you should start with a template. I said, you should start with a clean sheet of paper and use the wizard. We lovingly call him Scott, actually, but we use the parameter setup wizard. You answer 6 pages worth of questions, which is just a matter of checking boxes. And then by the time you're done, 80% of the configuration is done. So you have to set up half of the forms still manually. Unit data, the IP address of the monitor, the start time and such, various miscellaneous parameters, permissive channels. Of course, the monitor key wizard isn't going to say, oh, I looked at the controller and this is what should be permissive. However, in our controllers, and I'll get to this. Yeah, you talked about this, I think a little bit, and I think Matt did too. The controllers will calculate what the permissive should be after you configure them, which is why I put monitor key after the controllers portion of this session, because you program the monitor key after you program the controller, not before. Because we all have cheater screens inside of our controllers saying, these are the channels that are compatible with each other. These are the little boxes you check. And trust me, when I did the one for DuPont Circle, it's 28 channels. There's a lot of check boxes. The DuPont Circle concept, I should say. So you can then complete your dark channel maps, permissive channels, current sense thresholds, which you don't want to mess with right now because maintenance mode monitoring of a channel output is not done in the monitor, it's done in the controller. Flashing yellow arrow and virtual channels, like I talked about this morning. You fill those out, the wizard's already done the second half of that screen's forms. And then afterwards, you run the perimeter check wizard. This is the last thing you do before you burn this image to the data key, because the wizard comes back and says, yep, everything's fine. Or, hey, you checked the wrong box there, dummy. So don't step on the power cord. So there's a second check here for building this configuration to make sure that you did it right or the technician did it right. You burn it to you burn the configuration to the key. You save it to your machine, and then now you're good to go. You have a permanent data key. Now, people have asked me in the ATC cabinet trainings, especially there's one city in the Mid-Atlantic. I won't mention any names, but the guys from Philadelphia, they're obsessed with the data key in the regards of what happens if the data key is damaged in by any ways. Now, this is an electronic storage, or this is a storage device. I suppose you could hit it with enough static electricity to corrupt the image or the data on this device. However, we've never seen it happen. So then someone says, well, what if somebody steals the key out of the cabinet? All right, well, if they got inside the cabinet, then, I mean, what if somebody opens a NEMA cabinet door and steals the jumper card? Same difference. So the data key is an extremely stable way to store a monitor configuration and have the monitor operate normally. Okay, last section. How did I do on that one? Well, 1:13. I'm a little ahead of schedule now. We had lunch here. We're all kind of tired now, so may as well have some fun. Deployment experience. So I wrote this slide. I wrote these slides last year, I guess, for a user group that we held at the office in California in June, and I wanted to do something different with ATC cabinets, talking about ATC cabinets, because I used to just feed the same exact slides, and every presentation is different. The way I do it, obviously, because I'm a nutcase, but also the content that I put in here. But I love this slide because I wrote that presentation for the guy who asked the question, why do we care about ATC cabinets? Why not go with TS2 cabinets? All these things. And I thought, well, let's talk about cabinet number 1. So this is the first ATC cabinet ever deployed in Cedar Park, Texas, September 2014. So that cabinet's been running now for 10.5 years, with the exception of 2 switch packs that are added, and you can see the little yellow switch packs that are slightly different color. They were added for flashing yellow arrow, but otherwise, that cabinet's just run. Has just run, yeah, pretty much. But since then, we installed that cabinet and we're like, pins and needles. Okay, we're installing something brand new in the field. Is everything going to be fine? All right, so we installed that one. That was the hardest one, as for the company. Since then, Swarco McCain's acquired a great deal of knowledge and experience installing ATC cabinets. And it's not just Swarco McCain. It's Q-Free. I'm almost ready to drop F-bombs. It's Unix Traffic. It's Econolite Group. It's Mobotrex. It's Trafficware. We've all and it's you. It's Virginia DOT, Tennessee DOT, Maine DOT. Everybody's put in or City of Sevierville, City of Pigeon Forge. Everybody's put in ATC cabinets has learned a lesson, has learned valuable experience. Last month, I was at the Maine DOT traffic school. Forgot where I was. My own hometown. How stupid am I? And the Maine DOT staff and contractors had a lessons learned session. It was a 1-hour session where they talked about the first ATC cabinets they put in. It was called the Big Build Project in Augusta, Maine. And it was 100 cabinets in 3 cities. And it was a really fascinating session because they talked about their lessons learned from deploying the cabinets, installing the cabinets, maintaining the cabinets, repairing the cabinets. And I had already had this slide from June of last year, but I thought that's cool because we're all doing this and we're all doing this together. So the first ATC controller that the Q-Free installed, they were on the same pins and needles that we were on when we installed this whole cabinet in Cedar Park. As we go through the learning experience. So we're learning about this together. Based on everything that I've learned, when NEMA TS2 came out in 1992, it did not do as well in its first 10 years that ATC has done in its first 10 years. We've installed over 8,000 ATC cabinets since September 2014, which doesn't sound like a lot, but we also don't have machines building traffic cabinets like the automotive industry. Volkswagen, right over here, builds cars. We don't crank out 10,000 a day or whatever they do. All of us manufacturers hand build these cabinets. And we do use machines for some of the larger operations, but how many traffic cabinets do you think it takes a company like McCain or Swarco McCain or Trafficware or Econolite or Mobotrex can crank out in a year? As we also build Caltrans cabinets and NEMA cabinets and such. So 8,000 is a great number compared to the implementation of TS2, which some states are just now even considering going to. A lot of states have TS1 as their core spec. Where's my laptop? So deployment experience, construction. A lot of NEMA agencies adopting ATC cabinets, especially retrofits. They're learning lessons about constructions. Engineers draw a 36-inch pad and then they put a 60-inch tall cabinet on top of that pad. Can't get to the top without a step ladder. This was Pigeon Forge, Tennessee, April of 2020. That was a spec change retrofit, and then we put that on a pad, and we're like, oh, you can't reach the auxiliary display unit, which is at the very top of the cabinet. Therefore, we moved it down to the middle, because otherwise you need a box to stand on or a step ladder. Cabinet grounding is essential. So TS1, Caltrans, you can get by with a coat hanger over ground unless you have SDLC communication, because the grounding is simply electrical for the lamps and for the devices themselves. But when you introduce a serialized cabinet, one where the devices have to communicate with each other over a high-speed serial bus, a copper line bus that uses logic signals as the null, if there's any noise on that bus, there's trash on the communication bus. The devices cannot talk to each other. And then you'll get strange error messages like serial bus fail, or you'll have controllers where your communication ports, your SDLC ports, will fail. So we learned this lesson back when NEMA TS2 was around, but that was only for the agencies that adopted TS2. Now we're still going through that. Somebody calls me and says, I'm getting these weird errors on serial bus. And I said, what's your ground? Oh, it's 100 ohms. Okay, well, you need to crank that down to 20 ohms because that cabinet's not going to work well. So, that's a construction lesson learned. And then testing outputs, the field indications can easily be done. A lot of people say, oh, ATC cabinets, there's no test points. Yes, there are test points. They're on the back of the service assembly. So, we create these safe test points versus what we had to do in the NEMA world, which is just find a hot lug, which that works too. Another lesson, creating an agency spec. State specs, local specs, Canada, it's provincial specs. Creating a spec, an actual cabinet spec of what cabinet shell to use, the cabinet layout, what's going to go inside the cabinet, where it's going to go, so on and so forth. Vendors have been working with agencies, Tennessee DOT, City of Sevierville, Virginia DOT, everybody, to help create these specs and also just inform everybody of what's available inside our what's offered with an ATC cabinet. So and the differences of functionality between ATC and NEMA or Caltrans. So it's very important that we work to help create, or we provide input on these specs. So they're written in a way that doesn't use, we don't want to write an ATC cabinet spec and accidentally leave in the word incandescent lamp. So here's some examples of specs. Sevier County, Tennessee, like I said, they moved the auxiliary display unit from the top left to the middle because that's where they want it. This is a cabinet layout. That's a stock cabinet. We're just putting the assemblies in different places. There's nothing. There's no extra parts or components in here. Shelves and battery shelves. I mean, we put those in cabinets as well. But they just wanted to go away from kind of the standard layout that they would, if they just called us and said, hey, send us an ATC cabinet, we would have sent them the layout that we drew in the original design. And then they say, oh, we don't like that. So we designed this layout for them to meet their needs. Another example, Minnesota DOT, MnDOT, same cabinet shell as Sevier County, different layout, different assemblies, different components. This is exactly what they wanted though. MnDOT cabinets are cool. Not as cool as this one though. Maine DOT cabinets have a unique feature. The card storage rack in the upper right of the front bay is essentially a spare parts rack. So when someone drives halfway across the state and then they realize they forgot a high density switch pack, there's already one sitting in the cabinet ready for them. So they did that because, again, going back to soft costs, costs $400 to roll a truck. What if you send somebody halfway across the state of Tennessee and then they realize they don't have the right part, so they have to go back the next day to get the right, with the right part? It's already in the cabinet. So this is exactly how they wanted their cabinet laid out. Technician's panel on the inside. The police door is actually on the door itself. Technician panel on the inside of the police panel. The test switches like we had in NEMA cabinets. So we manufacturers, I'm gonna zoom out a little bit, work with DOTs, agencies, and consultants to help sharpen these specs to get, so the agency gets exactly what they want. MassDOT, San Jose, I always leave this one in here because this is actually a NEMA P cabinet with shelves. Not exactly my favorite type of cabinet, but they love it. They use this for light rail. So they have assigned layouts for all of the assemblies, and they also know where the space is. So you might be wondering why you keep showing me all these different specs. Because when agencies need to train new staff, when there's turnover and whatnot, or they need to do contractor training or whatever, they can wheel in the cabinet that looks like the rest of the 400 cabinets they have in their city, and they say, this is where everything goes. Standardized, it's uniform, and that's something that's I've seen a lot of different NEMA TS1 cabinets. I've seen a lot of different NEMA TS2 cabinets. So when you go to train somebody, And in one cabinet, the conflict monitor is on the left, and in another cabinet, the conflict monitor is on the right, and another cabinet, it's practically on the floor. If they forget what a conflict monitor is overnight, then they have to be, then that's an automatic phone call. That's 30 more minutes of telling that person what to do, and 30 more minutes of likely them getting frustrated, and then spending more time troubleshooting the cabinet. Austin, Texas, I left this in here because of these backpacks, actually. They kind of look like the ghost dogs from Ghostbusters, both sides, or, just sitting here. But Austin said, hey, can you make us a bigger backpack? Because it's Texas, right? So we stretched the backpack to 42 inches. I think these are 38 inches. So they could get detection equipment inside a little tall unit. So we built a custom back. We built a Austin spec backpack for them. All right, more deployment experience. Controller compatibility. We're fortunate that all three of these controllers here are ATC cabinet ready. The Blade has a C12S on the front. The Flex has C12S on the back. The XN1, shoot, whatever, sorry. The XN1 has C12S on the front. So these controllers are all ready to go. However, there are a lot of controllers out there that don't have those ports. So the picture above, I took that picture 3 years ago. That's part of my home lab. The Peak controller, that's a first generation ATC 1000, built in 2012, pre-ATC cabinet, completely pre-ATC cabinet. It doesn't have the communication port to connect to an ATC cabinet. The McCain EX2 next to it does have the communication port. And then I just took a stock photo off the internet. I think that actually came from Temple's site, but that's an old Siemens M50. I won't say Unix because that was built in the Siemens days. Maybe M40, I don't know. That is not going to be ATC cabinet friendly. So it's important to identify, as you're looking to upgrade to the ATC world, identify what you have, and if you want to put in an ATC cabinet, make sure that your controllers, the controllers that you're running are ATC friendly, and if they're not, then make sure to budget and plan for either upgrading or replacing those controllers. And that goes as far as the firmware too. Jay said earlier, CPAC 5.5 is the minimum firmware that runs on the Blade. CPAC 5.1 technically is the minimum firmware that runs on ATC, but why would you go that far back? So 5.5 was the first build that ran on the Blade. If it were me, I'd take, is it 5.7 now? 5.8, good God, you guys move faster than we do. Oh, okay, 5.7 then. We don't talk about unreleased software. No kidding. So CPAC 5.7, if it were me and I was going to make the leap, if I was a CPAC user, I'd be like, well, why would I go to 5.5 when there's a 5.7? That's 2 years newer. So you want to make sure that your controllers themselves are running the right firmware, both operating system and intersection control software. If you're running an old version of MaxTime, MaxTime 1.1 or 1.0 or whatever, and it was more designed for TS2 than ATC, then you're going to want to patch your MaxTime as well, or your Econolite software, ASC3 going to EOS. ASC3 doesn't support ATC cabinets. So again, I'm beating the horse now, but it is important to identify what's running and then mark that as either a task or a scope change to get your controllers up to ATC cabinet spec. Troubleshooting ATC cabinets. We talked about this and we thought, I'm just going to roll through this rather than playing past the mic. So each of these controller screens, Q-Free, MaxTime CPAC, and Omni, has these troubleshooting screens. And Matt and Jay talked about this. We have these status screens inside the cabinet that actually can tell us how well the controller is communicating with various cabinet devices. So in this case, this is the Q-Free MaxTime software. You can get to the screen on menu 177 or by going to status and cabinet status. and then show all frame stats, and it will tell you how well it's communicating with these particular devices. Q-Free has a cool feature. It'll actually tell you the frame number. So not only that it's talking to the ITS cabinet monitor unit, but the actual frame number of what frame is faulting, which the frame characteristics and the transmit characteristics are different for different frames. So if you want to get super nerdy and find out what frame 62 is, you can look it up in the standard. CPAC, same thing. They have a screen menu 25D. It's kind of a, forgive me for saying this, but it's a secret screen. So you go to 2.5 and it says, oh, you press E to go to diagnostics, but if you hit D, it loads this screen right here. It'll tell you what it's talking to. So terminals and facilities BIU 1.2, sector BIU 1.2, malfunction monitor unit. But it'll also tell you if any of those are offline, and if there are, it's going to count faults. You can hit C to clear that. And then bringing it home, Omni. Omni has a screen that shows same thing for ATC cabinet and also for TS2. So we split them up, and it shows frames being transmitted from the controller, frames being received from the target device, so an SIU or a CMU or a BIU, and then if there's any errors or frame errors. So we also have cabinet monitor unit operation status screens, configuration screens. We can read everything from Omni. So it's kind of like Nikita was saying earlier about being able to access the blade remotely and then catching a glimpse of what's going on while in the field. You can do that with any of these controllers. So you can get to CPAC and see screen 2.5D and the blade diagnostics. You can go to max time and go in and see cabinet communication status. You can get into the monitor via the ECCOM connection. And then with Omni, you can get in and look at load lamp out monitoring, but also SDLC communication and monitor active status. So there's a lot we can do, and a lot more we can do with this platform than we could ever do with TS1. Third-party device integration. This is more deployment experience. I get these calls all the time. I just had a call earlier at lunch, actually, where a guy says, hey, we're trying to wire in this third-party device, and we don't know how to do it. All right, you got to identify that. That could be scope creep. Oh, we're going to buy a whole bunch of ATC cabinets. All right, well, make sure that it works with your third-party device. Maybe we need to install a TS2 SDLC bus or something. Again, these are just things that we've learned over the years. Some devices require additional steps and such. We want to just avoid scope creep, and the best way to do that is good planning and mapping on everything that's up. And then the last one, I'll put down my little Olson cone. Test equipment. This is my favorite device. This is called a cyber cabinet. It used to be called ATC cyber cabinet, but it is now just a cyber cabinet simulator. Unix Traffic has some of these. I hope Matt buys one of these soon. This is a device that was built that we commissioned SRE Services, Scott Evans, to build for the city of LA. This is an ATC cabinet simulator. We expanded the functionality to support NEMA TS2 and Caltrans cabinets. So people are buying these so they can map out their complex intersections, so they can figure out how to, I showed you the Lemon Grove, California intersection earlier, how to actually make the intersection run in limited service when you call the preempt and you shut off half the intersection. I'm using it right now on a concept for DuPont Circle, Washington, D.C. Originally, that's 50 load switches. We got to figure out how to bring it down to less than 32, or how many cabinets we're going to need to deploy out there. So having this simulator is critical or not critical, but it is an extremely useful tool for manufacturers, vendors like us, Unix, Q-Free, and me, McCain, but also engineers and agencies looking to adopt ATC cabinets, reconfigure intersections. Up in Sevierville, there's a diverging diamond. There's 3 phases, 3 overlaps. We used Cyber Cabinet and figured out how to squeeze it down to 2 phases and make it even more efficient. And that thing's pretty efficient as it stands. So it's extremely helpful to have one of these simulators on hand. The cool thing about it is, just like the monitor key programmer I talked about earlier, this is your copy protection. So you inventory one or two of these for the entire agency, and you leave it in the drawer. You don't have to. Not everybody needs to have one of these devices. But they cost a couple $1,000s. I don't know how much they actually cost. Yeah, but you can inventory these and keep them on hand when you need them. So, you know, when you're concepting intersection design or modification or just testing preamps, we use these we use these with the blade back when we needed to see how they when we were doing software development with the front panel detectors. We wanted to make sure that we turned on detector 56 and that little light showed up on the detector status screen. So they're extremely useful, multi-purpose. I have 2 now, again, since I got mine back from Matt. And then last but not least, training and education. This is one of the hardest parts of my job, is recurring training. And that part's not hard. It's just, there's 52 weeks in the year, and I like to spend at least 26 in Maine because it's pretty there in the summertime. But it is imperative for us as service providers and manufacturers to not only just say, all right, here you go, here's your solution, bye, but to provide ongoing training and support in the form of user groups, in the form of webinars, hybrid events like this one. Ayrton, is this our 2nd or 3rd one of these this year? 2nd, okay. So it's only May, and I've already done 2 of these with Ayrton. We're probably gonna do another one in the fall. But it is important. It's our commitment to you guys as you adopt new technology. And it doesn't matter if it's an ATC cabinet or a traffic controller with new features or a whole new traffic controller platform. We need to continue to provide ongoing training and support. So as we come out with something new, or you guys, you know, go to bed at night, wake up and forget everything, just like we do, or all of us do that, we need to be able to continue to support everyone's investment in these products. Otherwise, we'll just turn into TS1 again, or the traffic controller will be, you know, oh well, we reverted it back to version 1 because we didn't like any of those new features because we didn't know how they worked. Okay, that was the fast version of my part. Let's pause for questions. Now, first of all, I will say that this slide deck, that didn't really work out too well. The little 1/3 of the screen's missing. This slide deck will be PDF, and I'll send it to Ayrton, and it's available for distribution. So I know we covered a lot of material. We've never done this before with 3 vendors. Last year I did it with Bill Lights and with Southern Lighting and Traffic, 2 vendors, and that was still a lot of material for, that was only a 6-hour, well, this is a 6-hour class too. But this will be PDF and distributed to everybody here who came to visit us at the TDOT auditorium, but also you Zoomers out there. Also, this is recorded too, so everybody will get a copy of the recording. So you have take-home reference. And all of our contact information right there, including Matt Q-Free. Let's see.
So Eric, I have a question here.
Shoot.
And I hope I don't put anybody on. How many providers of ATC cabinets?
Let's zoom out one. Let's do North America because there's one in Canada. So Soroco McCain, Econolite, Trafficware, which is, I'm sorry, Cubic Transportation Systems, Peak Orcs, Mobitrex, Taycell up in Canada. Am I missing any, guys? Orange Traffic, yeah, 7. See, there's 2 in Canada.
So my next question is, what you demonstrated today here with 3 different controllers, is that only doable with the Swarco, or is it doable with other cabinets as well?
It's doable with other cabinets as well.
Okay.
That's a great question because something I didn't really touch on. These cabinets are built, these two particular backpack cabinets, my little gargoyles here, they're built by Swarco McCain. We folded the metal, we built the assemblies. These pluggables, these are all made by EDI. So the protocols, if you actually read the ATC 5301 standard, they hard spec. They don't, I'm sorry, that's the wrong word. They call out functionality and reference EDI SIUs, EDI switch packs. I mean, it's essentially a hard spec because EDI is the only one making these components. There was another vendor who was going to come into the come on scene and make these components, but guess what? They were bought by EDI, actually EDI's parent company. So as far as ATC cabinet functionality goes, if they build the cabinet to meet 5301 spec, it should operate controllers. Now, I go back to what I said earlier. A Swarco McCain assembly will not is not a viable replacement part in an Econoline cabinet or a cubic trafficware cabinet because they use different connectors. I mean, they're the same dimensions and everything, but they might use a different harness. They might put this somewhere else. So be mindful of that part of it. We are all meeting the functional spec, but the cabinet builds are all different. But I should be able to take the flex and pop it in Mobitrex cabinet, and then take that out and put in a blade, and then take that out and put in a XN1. Good. Any other questions?
Larry is saying best practices or recommendations.
Is it a single input coming from a railroad cabinet, or is it a railroad logic inside of the traffic cabinet? There's
Single.
two answers here.
Single.
Single. Yeah, test it beforehand. Hence the cyber cabinet, wherever I put this. Last week I worked, I remotely provided the support for an agency up in Canada. My distributor went up there and swapped out a NEMA TS1 running an EPAC 300. Thing had been there for 20 years. They got their money's worth out of it. We put in a 16-channel ATC cabinet. We had limited service. We had 10 overlaps in that cabinet. And it took me 3 weeks with Cyber Cabinet to make sure that the configuration was good to go. And part of the trouble with that was an old EPAC 300, and we had no way to get the data off of it. So we were dealing with basically paper handwritten sheets. So test. Yeah, that's the first thing. Second, look and see what is inside the railroad pan, or what is scope out the existing railroad solution. Are you using a relay panel? Are you going to need an AC isolator in your input assembly? What exactly is what's calling that railroad input? And then identify what either needs to be moved out of the old cabinet or brought up to spec using an AC isolator or what have you. So do some research there. So research, test, and test again, and then deploy. Now, if it's the other type of railroad, we're bringing the actual gate down and XR signals and all the other like 5 or 6 signals into the cabinet. We have a railroad interface panel that interfaces with ATC cabinets. It communicates on the cabinet serial bus as an SIU, and we have a subject matter expert at Swarco McCain who handles all things railroad. So, but zooming out from McCain, test. If you're going to do it with Q-Free, if you're going to do it with CPAC, test. Those new logic gates you guys have in CPAC will come in handy with things like railroad. Any other questions? Cool. Any questions from the audience? Good. We're done bringing you guys food, so. By the way, I want to thank Mike Clance for handling the food today. It was our treat, but Mike took care of those logistics, so I could stay up half the night with the Q-Free and Unix team. right, putting the finishing touches on this PowerPoint. So thanks, Mike. If there aren't any questions, that's a wrap. Miller time.
All right, so thank you everyone online. I will be working on your certificates. We may not get 6 pages, we may get a little less than that, but that's all right. And I'll share the recording once I have it uploaded. If you have any questions to me or to any of the presenters, just you have the email addresses there. And hopefully we'll see you next time.
I have one more thing I want to say.
So, all right, go ahead.
Yeah, I want to thank Q-Free and Unix Traffic.
Yep.
Um,
And T-Dot.
and T-Dot. Oh, and you, Ayrton, of course. But I cooked this idea up actually after our last session, and I thought I'm going to send an email, and Mike and I talked about this. Mike is the regional or Southeast Regional Sales Manager for Q-Free, but I thought I'll send an email. I'll throw this up the flagpole over at Unix and Q-Free because we all know each other, and I hope they even respond to the email. And not only did they respond to the email, both teams, but they said, heck yes, when and where, let's do this. So I want to thank you guys. It's totally awesome that you got that we're doing this together. And I think we should do it again sometime. Yeah. 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 Matt Q-Free said thank you to everybody too.
All right, folks, we'll stop the recording and we'll see you next time. Have a good rest of your day.
Cheers. We gotta tell